You know, I'm very excited today because I wanted to organize a Python pizza in Brno for 5 years already, and we had a pandemic in between, so it made it very hard to execute, but we are finally here. So I would like to thank you, everybody, for being here to make this come to realization. I would like to thank Aneshka and Jake for being crazy enough to join me on this effort. And I would like to thank our sponsors, Barclays, Atacama, Red Hat, and EuroPython Society, which made this event affordable to all of us. Otherwise, we wouldn't be able to make the tickets for everybody with all the catering, the pizzas, and everything. All right, we will have talks today. They are 10 minutes long talks. And we will have a coffee break in the morning, lunch break for pizza, another coffee break in the afternoon, and some networking session at the end. I would like to have Peter Victorin with me. He's going to be your master of ceremony today. And now I'll hand it over to him, and I'll be busy with other stuff. Thank you.
Thank you. So you always need two people to thank everybody. So thank you, Moises, for being one of the organizers. There are a few things more I need to say. You probably did notice the coffee. Some of you did not notice the bathrooms, which are all the way in the back. Important information. I would like to ask any speakers if you would like to move on the stage. Please let me know in advance so we can set you up with a head mic. And that's it. It's time for our first speaker. Please come on stage, Lumir. And I think Lumir wants to tell us something about how his talk made it to first place. It was randomized, right? Please welcome Lumir.
Does it work? Ah, it does. Great. It's a little bit of echo. Good morning, everybody. Today, my name is Lumir, and today I'm going to talk about some random stuff, quite literally. So let's start with definitions. We all of them, right? So what is exactly a random number? You can imagine a random number to be something which is produced by the number generator in a way that it's unpredictable. You cannot really predict the result. And all the numbers from that generator should be equally distributed, which means that the probability you see a specific number is the same as the probability you see something completely different. It's like when you roll a dice or code in JavaScript or something. Even though you might be surprised how easy it is to create an unfair dice, but that's a different story. So you probably already heard about the random module, right? From the very beginning, when you start programming some card game and something in Python, and you want your computer to behave randomly. But if you ever open the documentation for that module, you saw that there is a warning on the very top of the documentation saying that the pseudo-random number generator of this module should not be used for security purposes. What? What the hell does that mean? Is it random? Is it not? Is it pseudo-random? What the hell is that? The pseudo-random number generators are very famous and very fast and very good, but not good for everything. So they are not actually truly random, because behind those pseudo-random number generators, there is usually a mathematical formula. It might be simple, like a linear equation, like something really simple. The simpler it is, the worse are the results, the less random they look. But they can still be good enough for many things, and I'll tell you which ones. And that usually requires something to start with, which is a seed that can be set manually, can be provided by operating system, and so on and so forth. And the problem is that they are pseudo-random, which means that they look random, but they are in fact predictable, which might be good, but bad as well. The seed provided is, in case of Python, usually the current time. You can set it also manually, which is good when you need to debug your program that relies heavily on some random information. You can provide the seed, and it will behave every time exactly the same, which is a good thing. Or it can be provided by your operating system, which is usually the case. And I'll tell you about the sources of randomness here. By the way, I'm safe. I have only 10 minutes, but the timer is not running, so sorry. So what are the pseudo-random number generators good for, you might think? For games, generating random maps and randomizing loops and behavior of NPCs and so on and so forth. If you need to now I have only 6 minutes, all right. If you need simulate traffic, if you need a population growth simulation, you need to shuffle cards or something like that, or you need randomized data for your testing and stuff. That's it. And it might be also helpful for debugging, because if you are able to make your program, even the one rely on random stuff, depend every time or behave every time the same, it's good because you can debug complex bugs. But what if you need true randomness? What if you need the input to be really, really random? And that's especially the case for cryptography and security communications and so on and so forth. Because if you think about it, the algorithms are well defined, right? We know how the algorithms for hashing and encrypting data, we know how they should work. So if the output of that algorithm should be unpredictable, there is something that has to be on the very beginning, be unpredictable as well, and that's the random input we are putting into those algorithms. When talking about true randomness and when you truly need it, I'm thinking about the SSH, HTTPS protocol we use every day, or basically any other protocol with the S at the end. They are all now with S because they have to be secure. And salts for pepper and hash, salting and peppering the hashes when you're storing password, many, many other stuff. And for that purpose, we have true random number generators. But the problem is that the computer themselves are deterministic machines, right? We code them, and we expect them to do exactly what we'll tell. There is not really much space for any random behavior, sometimes, I know. So the computers need external source of, usually physical source of randomness to start with, and that might be electrical noise, that might be thermal noise from the components in your computer, that might be atmospheric noise if you have an external device for that, and there are internet pages that use atmospheric noise to generate. It might be as well movements of your mouse or the timings of keyboard typing, or it might be timing of the packets you are receiving on your interfaces and so on and so forth. So the computer really need to be truly random, need an external source of randomness. And that makes the true random number generators, which are better, but that makes them slower than the pseudo-random number generators, more expensive, especially when you need an external device for them to run, harder to implement with much more requirements, right? But also more secure because they are truly random. So we might ask, can I have both? Like the advantages of both words in the same package? And the answer is yes, you can. And the result is called cryptographically secure pseudo-random number generator. And this talk is too short to repeat that, so please remember. And those use fine-tuned pseudo-random number generators and the true random number generators as an input for the seed I mentioned earlier. So it's a combination of both, and they work very well, and they are designed for cryptographic purposes and secure communication and stuff like that. In Python, there is secrets module for that. So if you are programming games or something like that, use random, but if you need something really secure, use the secrets module. And now I have a story for you, because you might think, there's plenty of space, something could go wrong, right? And you are 100% right. I'm going to talk about the CVE, pretty old, from 2008, which was in a Debian, in OpenSSL implementation in Debian Linux operating system. Let's make this a short story, but with a lot to learn from. So the OpenSSL library is basically a library on the internet responsible for a lot of secure communication, generating keys for your web servers, for your SSH communication, a lot of stuff. And OpenSSL uses cryptographically secure pseudo-random number generator, and very well one, very fine-tuned one. And the seed was generated for that pseudo-random number generator. So basically, the source of randomness here was the process ID, which is a small integer, 500,000 at most, I think, and the state of unallocated memory. So far, so good. Unallocated memory is usually full of garbage, and it's really fast to use on any computer, basically. But then, in Debian, they started to testing that with Volgrind, which is a tool that informs you, hey, you are using a memory in the wrong way. Like, you are doing something you shouldn't do, like double freeze, or you are using a memory you shouldn't, and so on. And the Debian developer decided, all right, there is a warning that the OpenSSL library I am maintaining is using unallocated memory. That's wrong. I should silence the warning. And he did. It meant to comment out 2 lines of code, which basically almost completely removed the source of randomness from OpenSSL library, which then made all the results of OpenSSL 100% predictable. So the attacker then can completely predict all the results of OpenSSL library. And that means there are only 500,000 of the possible combinations because of the PID. So if they capture encrypted communication, generates 500,000 of keys, try all of them in, I don't know, 2 seconds, 3 seconds, something like that, and that's it. The problem was even worse because it wasn't just only necessary to update the OpenSSL library to newer version where the fix was deployed, but you have to also discard all the keys, all the secrets, all the hashes, everything. It was millions of dollars. So the answer for the initial question, can computers generate truly random numbers? No. No with the help of some external source of randomness. Is that a problem? No, not really. If you know what you're doing, it's not a problem for you. Thank you for your attention.
As you can see, we can start some of the talks early if the speaker is lucky, they get extra time. We do have to end on time, so the next speaker can have at least 13 minutes.
All right.
But yeah, we have some time for setup and things.
And hey, to set up this one, there was a...
So
This, sorry, which is that? Ah, this one, okay.
Okay, there's time for what? Signing up for lightning talks. Yes. Yeah, you could have done that a few months ago. Right, I think we're... Oh, the computer is almost set up now.
We'll see.
Is it working?
Yes.
All right. Mela, please tell us what not to do.
All right. I need to move, please.
Oh, you need to move.
Yes. I'm free spirit. I need to. Are you hearing me? Yeah? Okay, thanks. All right. Hi, my name is Nela Slezakova, and half a week I am working as a psychologist / psychotherapist. And in other half of the week, I am being a Python programmer. I know it's a weird combination, but also it allows me to deliver some interdisciplinary speeches like this one today. And today, we will do some preventative fight with burnout, so you shall not burn out. All right. Most of you are probably familiar with the progression of a typical programmer. If, as you start, they call you junior, you know, almost nothing. But, like Jon Snow, that's not a problem. Then you know some stuff, or you look like you know some stuff, and they start to call you a meteor. And after sticking in the industry for some time, they start to call you a senior. And then you burn out, and then you start working as a mechanist or a gardener or, I don't know, whatever, just something tangible, something where you can touch the results of your work, finally. And this is a bit of a joke and ain't a joke at the same time, because this job can really wear you out. And actually, the programmers, along with helping professionals, are at the highest risks of having burnout. So, what is this burnout? In the contrary, with the popular belief, burnout is in the classification of International Classification of Diseases, but it is not listed as a mental illness. It is listed as a factor influencing your health. This is the exact definition. And we call it a result of chronic workspace stress that has not been successfully managed. To put this horrible definition very simply, in bad work environment, you may in time feel very bad, obviously. All right, one way how to define this bad work environment is to talk about human needs and their deprivation. One famous psychologist called Maslow said that your needs can be grouped in sorted in groups, and they are hierarchical, so we draw it like a pyramid. At the bottom, we have some physiological needs, like food, sleep, and just enough of stimuli, not too much, not too less. Then we have needs for safety and security, stability, order. We need to be loved and liked, to belong somewhere, be respected and valued, and also to do something we feel like doing, like we are good at, something meaningful to us. All right, and people think that they can hack this. Like, I don't know. They say they can handle it. I don't know. Not enough pauses, skipping meals, have a ton of work. Yeah, I can handle it. I'm strong, right? And also, there is chaos in my team. I don't know if they will have enough money to pay me the next month. And my working conditions are changing constantly. Yeah, well, I can handle it. I'm strong, right? And my boss is yelling at me often, or my colleagues are, I don't know, they don't like me, they reject me, or I feel isolated. Yeah, I don't need my boss to like me or be my friend, right? No problem. No one will recognize what I'm doing, like saying some praise. I only being micromanaged and not trusted. Yeah, I know I'm capable, I can handle it. And doing some stupid, meaningless work and task and features no one will use. Yeah, well, at least they pay me well, right? I can handle it, I can handle it, I can handle it. No, one day you cannot. Just like every one of you has some certain level, they need to have this needs fulfilled. It's individual, yes, but you always has one. We are seeing some land registers being hacked these days, but this you cannot hack. Yeah, Slovak knows. All right, how does it feel if you burn out? There are 3 key symptoms, which first is like overwhelming tiredness, that no amount of sleep will help you, no amount of rest will help you, just energy is completely depleted. You hate Sundays and Mondays and every day. You feel like angry and disgusted, desperate for most of the time, and you are ineffective. Work that will take you 1 hour before now takes you a whole day. And the result is like pitiful. You know, you stare at the code, you know you should know what you are doing, but there is this monkey with symbols, like, and empty. Well, yeah, I cannot like pinpoint how this sucks really, but my clients would tell you that if they could go back in time and to handle this sooner, they would, because, yeah, it's not pleasant. All right, but just to clarify one thing, I don't want to overhear that all Brno is having burnout around their releases. This needs to take some time, like not only one day to have ineffective or being angry, it's normal, but if it takes months and it is getting worse, or years, I hope not 3 years, that's what we call burnout. All right. Let's say I convinced you that this is not something you want, and you would like to know what you can do to prevent it. It's just, I don't know my time. Okay, I'm good. It's very simple, and it's not at the same time, because in every time, you know what feels good to you and what feels wrong. If you feel like being valued and secured in a job and everything else I mentioned, you know. From some reasons, you may choose to not to listen to yourself, but I think the only way how to prevent like doing this burnout thing is to listen to yourself. And yeah. It can be tough of a cookie because if it's not, we wouldn't see burnout being on the rise these days, but it's doable. And if you need support, you can always reach out to a psychotherapist. We don't bite, maybe, only sometimes. And yeah, and if you would take good care of yourself, you are not going to burn out. All right, that's fun. That's fun.
Thank you, Nilla. And now it is time to welcome our next speakers. There's just one of you, right? Yeah, so this is the smart thing to do, get some help setting up your computer. For free? Oh, I don't know if there's money involved or some other services. All right, so this is a tried computer. It worked before and it's working now. Please welcome Sam with AI Agent.
Thank you. Hello, everyone. So again, my name is Samuel, and I would like to present you this library called Autogen, which is a framework for building AI agents and applications. You can pip install it as usual. What is Autogen? It is developed by Microsoft, but do not worry, it's not Clippy 2.0. It's something else, so keep your jokes aside for now. Anyways, inside it's basically wrappers around LLM, around large language models. If you haven't heard, I'm pretty sure you've all heard. And you can have multiple AI agents underneath, or like coded in your code. These agents react to events. It can be messages, triggers, and they can produce responses or some actions. And underneath, it's a event-driven architecture. That's how they developed it. You can think of it like a well-organized group chat, except your friends are AIs with their specified roles, or like specialized. Now I would like to introduce some concept which is called Society of Minds by Murray Minsky. And it is some kind of decentralized model theory which says that the intelligence emerges from many simple specialized entities, in this case agents, who are working together rather than as a single entity. Each agent can handle a specific task, and the interactions then create complex thoughts and behavior. You can think of it as a project manager, basically, or like some feudal king who is overseeing the team. He delegates the tasks to his knights, and but the experts, the knights, have their own autonomy. And in Autogen, this is modeled as an internal monologues. So they don't communicate, the agents don't communicate with each other, rather they communicate with the king, and that's how they appear to the external world as a single agent. This is what happens if you are going to OpenAI's ChatGPT and you hit O1 model or whatever. You're going to input some data, and then it says analyzing, thinking. behind the scenes, what we think is that this is actually happening. The agents are at their work. OK, now I would like to present you some demo, how it looks like in the code. And we're going to be doing stonks analysis. There is a group chat manager who is behind the scenes of the Society of Mind agent. And this group chat manager manages two agents. One is the regular assistant agent who is generating the code. And then there is a user proxy agent, which is equipped with Python and with the Python execution. So it executes the code. These two agents basically return results. They execute the code, communicate with the group chat manager, and then to the Society of Mind agent, and respond, etc. Regular stuff. Import Autogen. And there is first assistant, which is the inner assistant. That's the generator of the code. Then there is interpreter, who is generating the who is executing the code. Here we can set the human input mode if you want to make sure the code is executed. The code you are about to execute is good enough. You are not removing everything from your disk drive, right? For example, it can do it. You can encapsulate everything into Docker, which is good, because you don't want to break your own environment, right? If you're working with some AI-generated code, you always need to oversee it if you need that. You can specify a working directory, and then it's executing. Then there is this group chat manager I was talking about, who is having the assistant and the code interpreter as its peers, as its agents. And there is the Society of Mind agent, who is having the manager as a chat manager. Then there is a user proxy, which gives out the task. That's us, in this case. The task is simple. Compare SAP 500 with MSCI World Games over the last 5 years. And we initiate the chat with the Society of Mind, and we give our task. May I ask question, where are the prompts for myself, or where did I put them? Nowhere. They are behind the scenes in the Society of Mind agent, who is delegating the task to the agents, and he is actually the one who is doing the prompts, or like saying what they should do. So this is the first reply to compare gains, blah, 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 all the rest. Yeah, we need to use Y-Finance library. It pip installs it if it is not in the Python environment. Yeah, there is also pandas, for sure, which is handling all the data. It specifies the end date, the start date. The data are being downloaded from the Yahoo Finance, and then we are taking the adjusted close price. We want to do some cumulative sum on the percentage changes, and then we want to print out the data, right, on these two tickers, which are correct in this case. Is it good? Is it not good? One may not know until you execute. And when you execute, you're going to see some problem with the code. And that's that this column is not present. It raises an error. The executor says that there was an error, and it should repair itself. This basically is what the response looks like. The chat manager, as you can see, this is the inner assistant, who is generator. And it is modifying the code to print the data after downloading it. It goes back and forth a couple of times. I mean, this is a kind of pricey. If you want to save money, you don't want to do that too often. But if you want to have like really good code, which is working, you want to go for agents. And in the end, I think this is really impressive. In the end, it was successful in generating the proper code, which downloads the data, prints them out, and then, after fixing all the errors in the meantime, it is able to calculate the percentage change over the last 5 years, as we asked. And this is finally a code that debugs itself. This is something I was dreaming of, actually, because when I was in the university, I was always like at the C codes, and I wasn't like knowing, like, oh my God, there's this syntax error. I have no idea where this is line above, this line below. I don't know. Now, I don't need to think about that, right? I can just generate the code with the help of agents, for example, if I have enough money. So yeah, this is the response of the Society of Mind agent. It basically summarizes up everything we've done so far, or like they've done so far. And yeah, I find it really impressive. There are a couple of alternatives for, like, instead of Autogen, you can use Croy. LangChain also has its own libraries, such as Graph Chain, I think it is how it's called. Or if you want to DIY yourself your own agents, can be local LMs, or whether you can use Hugging Face for that. Or you can scan the QR code. This is my presentation if you would like to know about the sources. There is also a repository with more examples. And if you're going to go to the documentation of Autogen, you're also going to find really, really nice notebooks with examples on how to make these agents work. And that's it for me. Thank you very much for your attention.
Thank you, Samuel. I think you're the next speaker, right, Dmitry? Please come on stage, set up. No, the lightning talks are much more calm when there's time to make them, so I'm really happy that the production didn't take much time, and now we can just see how the speakers are doing, connecting their computers. Now you still have about 10 minutes for this, so it's great. Are you ready? All right, so Dmitry.
Can you hear me well?
Yes, we can. Right.
Sure.
Please welcome Dmitry.
Hello, Brno. Hello, Python Pizza. It's so great to be here, and let's go. So, my name is Dmitry. I work at Microsoft. I'm a software engineer, but what do I do here? Because I write in C# right now, and that's it, just C# and nothing else. But I used to be a Python developer for quite some time, like I used it for 5, maybe even 7 years, I don't remember exactly. And you know what, I still love Python as a language. I love the community in Python, and again, it's so great to be here. Python is a great language, and it's like, sometimes it's not the perfect fit for the purpose. So I'm gonna say a few words about how great C#, which is statically typed, and yeah, it's just not great, but I will show you how this can look this big. It's like, can you imagine? It's been so cool because the language is developing, and it's like, wait, what is he talking about? But let me finish, because it's all about the boilerplate. So look at this picture. If you can see the code, it's like, we have using system namespace, blah, 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 whatever. It's not cool. I mean, the light theme, of course, and the only meaningful line here is this one. So yeah, see, we have to write, I don't know, how many was that? 4, 5, 6 lines of code that don't actually do anything. And you have to get, like, I don't know, 40 inches display just to read all this stuff, like private, public, static, whatever, blah, blah, blah. And nobody wants to do it. And when you read this console write line, it's on the rightmost end. So you basically cannot go there. So what if I told you that you can have this at the content of your C# file? So yeah, that is, you can write code like this. It looks like a script. I mean, it's still C#, but it's a script. It's the same as Python. You could write print hello pizza or whatever else, and that's it. So it can generate all this boilerplate stuff during compile time and blah, blah, blah. It's cool. It's a nice feature. And yeah, that's just how you run it. Next. I remember times when you had to write all this strings, square brackets, names equals new strings, square brackets, blah, 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 whatever. It's not cool. You could just, I thought I was going to die of old age just writing this, just reading this, and it's absolutely not cool. But look at this, collection literals. Now the collection of strings looks exactly the same as in Python, except the type declaration, but it's cool. And yeah, of course, the for each loop, it's a bit different than Python's for each loop, but come on, it's still cool. But you know what? Here, the only thing that bothers me is this really, like, I would say even ugly console.writeLine. Oh, actually, and we have string interpolations. Well, like all the cool guys who copied it from Ruby. So the console write line thing is not like, it's too verbose. It's just too many words for printing something in the console. But what if we could do something like this? Well, you would never push this to production, but come on, you can use it in scripts or whatever. I don't know. It's handy, it's cool, and this example shows you that you can easily assign methods, functions, or any other stuff to a variable in C#. So it looks almost the same as Python. So you can just write action string print equals console write line, and boom, you have console write line right on your fingertips. And see, print hello pizza, it looks like Python 3, but with the semicolon. I don't think you can get rid of those, but yeah. So basically, this simple example, it looks like this. I intentionally messed up the titles here, Python and C#, yeah, just for fun. But actually, sometimes it looks so concise and almost as eloquent as Python, and you could actually write, I don't know, proper code with it that actually has meaning, and you could understand what it does. Isn't it cool? So, as I showed you, you could, with the collection literals, you can also instantiate hash sets, which is just a regular set in Python, and it looks almost the same. It looks cool, and I like it, because each year when I see a presentation about C#, I think to myself, like, wow, these guys steal features from Python. Now we have Microsoft Python, that's cool. But the only thing that actually bothers me a lot is the dictionary literal. As you can see in the C# column, it's a bit, you know, still not great. But I mean, it's better than creating the dictionary and adding one by one like it was before. But anyway, it's much better now than it was. Thank you.
Thank you, Dmitry. All right, so we asked the speakers to give 10-minute presentations, and it looked like they all fit in the 10-minute limit, which means we have more time for what's called a coffee break. You can treat it as a coffee break, or you can have any other kind of beverage. You can also treat it as a Q&A session with the speakers if you happen to find one and happen to have an interesting question for them. They might be happy to answer your questions. And yes, good call there. You don't have to listen to me speaking here. Just go get coffee. We'll come back, I think about 11:14. Be a bit earlier for the next session. Right, see you. I hope you enjoyed your coffee or anything else. Please take your seats now so we can start with the next round of talks.
There's head page on this side.
All right. And all the technical issues are solved. So, we are on time. Please welcome Sharka with her talk about time.
Good morning, my name is Sharka Jana, and I'm going to steal 10 minutes of your time to talk about time management hacks. When I was 23, I was studying and I had 2 jobs. One of them was a full-time job. So Nella would probably say I was on a way to burnout. But I actually decided to try to gain all of the knowledge regarding time management and to improve my skills. Since then, I've worked with students, elderly people, people in business administration, in marketing, with technical writers, and with developers. And at a certain point of time, everyone came with some question regarding how to improve their time management skills. When talking about time management, it's usually about getting tasks done or even started, getting them done effectively or quickly, or getting done the right tasks or in the right order, which is about prioritization, but I won't be talking about the third one. I will only focus on the first 2 categories. So let's dive in. What you can do for yourself. It's very important to understand your motivation and attention. Why do you want to do this task, or even why you don't want to do it? It might help to overcome this as well. What's the basis thing here is that our brains use dopamine, which influences motivation and focus. So you can also recall the good feeling that you had when finishing something. And this helps us also to determine which strategy you can use at the beginning of the day. You can even start with the low-hanging fruit, meaning doing something that's very easy and rewarding to get the instant hit of dopamine so that you feel good and motivated into doing something more. Or you can start with eat the frog, because it's in the morning, it's the start of the day, and you have still wide attention span, your energy has not been depleted, so you can start with the difficult task or the task that is most complex. Second thing that's important to know, have you ever felt that you are trying to figure out any other different activities instead of doing your task, or that you have struggled to even start it or make it done? Then, welcome our friend procrastination. And one thing to know about procrastination is also that it can be sometimes hidden perfectionism. And maybe this one could prevent me from having this talk here, because I would like the presentation to be like Simon Sinek's talk. But I have to overcome my limitations and talk and think about done is better than perfect. But procrastination can have many more reasons. One of them could be, for example, if this task is poorly structured or if you have not broken down it into smaller tasks. With which we come to planning as an important part of everything that we do. So I usually go to my diary and plan for the week. I try to put the time slots of my meetings and then decide what's the biggest topic for this week that I have to tackle. Then every day, I look into the day in detail and determine one major task that I'm focusing on, and then some administrative stuff as well. And breaking down the tasks is important here as well. Time boxing is a really important thing and game-changing for me. It's a way to fight the Parkinson's law. What's Parkinson's law? It's the way to describe a phenomenon that is talking about the task's expansion. I'll give you an example. If I plan Saturday as the day for cleaning my house, I can literally work every day during the whole day and not get things done to the state that I wanted. But if I know that in 2 hours a friend of mine is coming for coffee, oh yeah, I will get done everything so much quicker. So time boxing, putting a specific time frame, a time slot for any of your tasks can really help you to create this artificial deadline for you and help you things done. And it's not only for like bigger tasks, but you can also learn to do task batching, which helps you with your cognitive load. Because switching between tasks will deplete your energy much faster. And as engineers or people in creative positions who really need to think about things and come up with new ideas, it's basically good to have uninterrupted time for your work and reduce context switching. How long should be this time box or the time slot that you have? I call it double Pomodoro and flat white. It's my term. You won't find it online. I should have put copyright on that, but never mind. You maybe heard about Pomodoro, which is a technique that's good for students. 25 minutes deep work, and then 5 minutes break. But for engineers, it's not that good, because you need more focus time for tasks. So double this to 50 minutes, and instead of an espresso that you can drink within 5 minutes, take double espresso, which is flat white, and have 10 minutes break. Also, another good technique is 90 minutes of deep work, focused work, and 15 to 20 minutes of breaks. And be mindful of not skipping the breaks. That's really important. Focus on some activity that would help you to unwind, go for a walk, stretch, listen to some music, anything that makes you happy and protects your energy. And also be kind to yourself. When you work hard, you really need to have a good sleep, good meals, and if you feel after a week that you really deserve a weekend when you just do nothing, then don't do anything. Your brain is not for storing things. So use anything else. Use a notebook, use Zettelkasten method, anything that would work for you so that your brain can focus on thinking. And optimize your environment so that you get to a flow state. And this is very different for every one of us. So think about what would make your life easier. It can be, for example, having some music on, like low fidelity, or, for example, some binaural music, reduce digital distractions, or even have some visual cues. Like to-do list or motivation board, whatever you find helpful. And one of the questions that was also a game changer for me to feel really good after a working day is, before I leave for the day, I try to ask myself, what is the one small task I can do now and which makes my next day better. And it should be really something small, sending that one email, some Jira housekeeping, or even at home, doing the dishes, you name it. And this could really help. And don't forget about reflection, because if you implement something, try to stay consistent and try to ask yourself, how do you feel? What should be adjusted for continuous improvement, and so on. And yeah, that were my tips, basically. The bad news is that time flies, but you are the pilot. So implement one thing from this presentation or from anywhere else today, and you will get one more day for free. So thank you very much.
Thank you, Sharka. All right, do we have the next speaker? Lukáš, there you are. All right, please take your time. Connect your computer. I think you can just close this one. And here's the cable. All right, so you have 2 minutes to switch slides. And now we will hopefully see something about an entity component system. Does anybody know what that is? Oh, you. Okay. You do your job then, Lukáš.
So, hello. Entity component systems. Do I need some microphone or here? Yeah, okay. Entity component systems in Python. So,
speak closer to the mic.
Okay. So, first of all, my name is. Can you hear me through this? Whatever. First of all, my name is Lukáš. I work. Yeah, this one. Okay. Let's try now. Okay, my name is Lukáš. I work at Kiwi.com as a backend developer. There are some links for me. Mainly, you can see the GitHub. All of the code that is in the presentation will be there. Also, the source code for the diagrams, if you're interested into that. Let's get right into this. There was a question about entity component systems. Does anyone heard about them before? There is one hand. Nice. Okay. Nice. Okay. So they can be thought of as an alternative to the object-oriented design, so to speak. So let's first remind ourselves about that. I presume most of you know object-oriented design, but let's say you are writing some product management software, and this software would like to sell books. You create your book data class, and the main point that I would like to point here is, except for the identifier, the book class also holds and enclosures all of its data. It holds its price, its names, its descriptions. It encapsulates everything that book should hold. Then also sometimes it encapsulates its logic. That can happen. When you want to, let's say, alter the price of the book, you fetch your books, you iterate over your books, and you just update the price of the book. For example, here we discounted it for 15%. This should be kind of straightforward, I hope. Let's compare this with how we would do this in the entity component systems. First, we have the entities. Entities in entity component systems are just containers that hold your pointers and identifiers for your entities. But this is all they do. The only thing they should hold is the entity ID, which is the identifier that identifies this is book 1, book 2, book 3, this is magazine 1, magazine 2, magazine 3. They shouldn't hold any other data, and they shouldn't hold any other logic. So just identifiers. You may be asking, okay, where are my data then? For that, we have the components part of the ECS. Components are containers that hold your data. In this case, I chose list as a container, and the rest of it is just helper functions to load and set prices. But in this case, we have lists. It doesn't have to be necessarily list. You can use the dictionary that can be keyed. Dictionary ID can be entity ID, and the value can be the value of the price, for example. You can use even objects. But important part for this is it is a container that holds only one type of the data that you have. So we have one container for prices. You have another container for descriptions, names, whatever. This holds only your data and like code for fetching or storing the data. So where is my logic then? Your logic is in the Your logic is in the systems, what we call systems. This is nothing else than just a way to store the logic that, for example, discounts your book in this case. It accepts the component. This is the container for the prices. It accepts it, iterates it over it, and updates the prices of the books, for example. Same as before. So why did I choose list? I would like to talk about that a little bit. When you look up talks about entity component systems, quite often you see that cache coherence mentioned. What is cache coherence? What is cache maybe? When you want to update the price of the book, for example, the processor loads or your program loads your book from the heap in the RAM into the processor cache. Cache is a memory that is baked into the processor, and it's much smaller than the RAM, but it's also much faster. You want to use it as much as possible. I will do some simplifications here, but more or less this is correct. So in this, the idea behind this is when you load your product object into your cache and you want to update the price, the objects itself, they don't actually hold their own data. When you access book.price, you will only find pointer there that points to another point in the memory, and needs to go to the RAM to fetch the actual data and work with that. This is what we call pointer chasing or cache miss, and it's something you don't want to do. So in this case, the idea is you have your array or your list. You have all of your data neatly packed together. Therefore, you fetch all of your data into the cache. You iterate over your cache, and you move fast. So that means I have my data in my list. Does it mean I will iterate over this and I will go fast and use a lot of cache? Actually, no. You see, Python lists are objects. You probably heard everything in Python is an object. That equals lists. They are very flexible. You can put different types of data there. You don't worry about the memory of the object. You don't have to. You can do nearly anything you want with them. Some low-level languages, this is impossible. They are much more flexible in Python than in these. However, this has disadvantages, if this works. If you look into the memory, this is just a bunch of objects that point to each other. And this is exactly what we said we don't want. So we have your prices variable that points to the list object, which is your list. If you want to access the data, you have the item parameter, which points to another array, which even the array don't have your data. It only has pointers to the other objects in memories, which actually store your data. And even the integers, the Python objects, they itself are objects that if you want to use them, you need to look at the object type, and you will find the Python type that describes how this object can be used. This is a lot of information, but basically what you want to get from this is there is a lot of objects, a lot of pointers, a lot of pointer chasing. So that means we are done. We cannot have the cache coherence in Python in our objects. Not really. There is another type of list in Python, and NumPy goes to the rescue. Sorry. So yeah, NumPy, compared to the classic Python list, it actually holds its data. And you can type the data inside to actually so it doesn't hold the Python integers, which are objects, but it actually holds the real integers. So we create our new component that holds all of the data in the NumPy fields, and we create another system that can work with this, and we iterate over it and we go fast, right? So this was the point where I was originally wanted to show you some really nice graph that will show you how we have no cache misses and how we are much more efficient. The code runs, of course, orders of magnitude faster because of the NumPy, but this is where I learned that measuring cache coherence in Python is really, really, really hard. Most of the cache traffic that was generated by my setup code that was generating the entities, not actually the updating code. when I was trying to separate the program into multiple parts and run only the parts and then subtract the numbers, you get weird numbers because each time you run it, you have completely different numbers. And yeah, it's really, really hard. So, and also we use the vectorized operations here. That means the NumPy does operations on the entire arrays. It doesn't fetch and iterate number by number. You would probably get much more success if you rewrote this into the Triton, but I didn't want to make this into the performance talk. So let's go back to the ECS and talk when you use it. And let's have some conclusions. So basically, if you do, when I was playing with this and when I tried different components and different systems and I was plugging them and playing and switching them, I kind of really liked how it works kind of like a Lego. You have, everything is super separated, super decoupled, so you can just plug and play and go. If you do a lot of operations with a batch of data, or even you know that you will need this NumPy optimizations or optimized stuff, this is probably not the worst way to structure your applications around it. Maybe you don't like object-oriented design that much. You have your clean code, you have your DDD, domain-driven design, you have abstractions. Maybe you would like something more like functional-like. This may be up your alley. Or you are doing some GUI application. You want to update a lot of stuff on the screen at the same time. This may be also interesting. But I would say this is mostly for batch processing of data. If you don't have too much of batch processing, if you don't have too much entities, probably not for you. So yeah, that would be it. I hope you learned something about ECS, and I will be running around if you have some questions.
Thank you, Lukáš. I think they missed a screw there. All right, who is next? Tatiana, that's you. Please welcome to the stage. I'll move that for you later, so please get set up. And the next talk is about simplifying DevOps. Does anybody know what DevOps is? I'll talk to you later. So let's see how will we simplify that. Is HDMI working? Is that your slide? What is this? Does anybody recognize the logo? Ubuntu. Is it Ubuntu? It's the default wallpaper. Right? And there we go. See, I wasn't lying. Is the right talk. Right? Everything working? Great. Please welcome Tatiana.
Can I get your mic? Okay, so hi everyone. Today we will talk about how to simplify your DevOps life with Python. And my name is Tatiana Kukhelna. Currently I'm transforming from Python developer to DevOps engineer. Yeah, it is a bit strange for a girl, but yeah, we have what we have. And I would like to talk for the first what is DevOps. Because we need to understand about what we are talking. And it is about automating integration, about deployment, about managing infrastructure, configuration, monitoring, and of course testing. And what is the goal for all of these? It is make the CI/CD process faster, easier, and reliable. And what does DevOps involve? And I think that we could start with CI/CD, continuous integration and deployment. It's about automating code integration and delivery, where we could use GitHub, GitLab, Jenkins. After we could see infrastructure as code. where it is about managing infrastructure through code, where we could use Terraform, Ansible, Pulumi, and also I could note that we will speak a few of them, like with examples, with code, to understand how is it used with Python. The next, I would like to speak with configuration management. It is about automatic system configuration, where we could use Puppet, Chief. Sometimes we use it, sometimes not. It depends of our project and about technology with which we work. The next one, it is monitoring and logging. I think that it is one of the famous applications which we could use. It is Elastic, Grafana, Prometheus. I think we all use it because I think that it is must-have, actually. The last one, it is cloud and containerization. It is deploying apps efficiently, and we use for it Docker, Kubernetes, OpenShift, and the last one I will speak later, because I want to say that in DevOps life, I think one of the modern thing which you could use for your workflow, it is Kubernetes, and for this thing, I think that one of the best idea which you could use, it is OpenLens. It is the last one logo, because there you could see everything. DevOps, config maps, secrets, your pods, all infrastructure in one idea. And we will back for Python, because as we know, Python has a rich ecosystem of libraries and frameworks. And one of the points of Python, it is cross-platform capability, because we know that if we will write some code in Python, it will be capability with Linux, with Windows, with macOS. So maybe you will need to change some little things, but in the main base, it will be the same. For this section, I would like to speak about these libraries like Fabric. It is interact with SSH for application deployment. The next one, it is bottom 3, which interact easily with AWS services. The next one is Python Terraform. It is a great library to manage Terraform configuration. And the last one is Azure MT resource, which could help you to manage your ARM templates programmatically. And the next slides, it will be examples where we see how Python can use and how we can use Python for the whole of this. So here it is Fabric. I hope that everyone could see. Every our script will be start with import, of course, because we need to import something our library to work with it. And for the start, we will use connection function to connect to our server, where we, of course, need to use our credential to connect, of course. And after we get it and run the run function, where we restart our application service, and also with it we execute shell commands on the remote server to pull the last code. In the next example, it is Boto 3. We could see how we initialize our AC2 instance for AMI. Is it Amazon Machine Image? And also instance type. And after it, we see that we need to wait until we're running our instance, and after it, we can print our public DNS name from this instance. So it is the same, like simple but work example. The next one is Python Terraform. The same, I think that's one of the famous application which you could use is Terraform, but also you can see how Python could manage it. So in the beginning, we need to initialize our Terraform client, where we create an execution plan and apply the configuration to provision the infrastructure. So you can see init, plan, apply, everything simple, work. The next one is Azure MGMT resource. We see that we import a bit more different libraries, but nothing scary. For the start, of course, that if we work with something like that, we also need to initialize our Azure, our client, which is Azure in this example. In the next step, we see how we need to load and prepare our template to work with it in the continue, and after we see how we configure our deployment to run it in the last lines, and of course that for some logging for us, we need to print it to know that everything is fine, everything is run, and deployment completed. The next section about what I want to talk is cloud and containerization, and here I want to speak about Docker, because as we know that it is platform for some action with application inside containers. The second one is Python's Kubernetes client library, which can have you interact with Kubernetes API. And the last one, it is Google Cloud Resource Manager, where we could manage our deployments. And this Google Cloud Deployment Manager could help, could give you opportunity to use all resources for your application, and as you need it, and declarative format is YAML. So you just need to know about it, because it is a bit and other things which we see previously. And the last one, it is Ansible. Actually, about it, if you are interested, I had a talk last Python Pizza, so you could find my presentation if you are interested about it. And in the next slides, I want to speak about our examples. It's about how we initialize our Kubernetes clients, how we could listen our pods and print the status, what is a pod. Okay, I see that I'm a bit over time. So here we could see how we work with Google Cloud Resource Manager. The same things with deployment, with different variables, and of course the result, how is it our states. One of the things is its interaction capabilities and security. The great thing is about Jenkins API, because it is interact with Jenkins servers, and Paramiko, because you can interact with SSH communication, cryptography for data encryption, and a few examples for it. So you can connect for your Jenkins, create a job, run it, and build it. The next one is Paramiko. You can see how you use cryptography. Yeah, and the last slide, it is how we can use Python for our logging. It is Prometheus, how we can get a few metrics and how we can see it. And the last thing is OpenLens. It's what I said previously. It is IDEA where we can see everything, so it is a really great tool. And in the end, I want to say, don't be afraid about DevOps. Python will help you with everything. Thank you so much.
Thank you, Tatiana. We need some time hacks there. Vladia, could you really quick? Yeah, that's a good strategy to take my mic. So yeah, speakers are expected to talk into the big mic. Rubber chicken. Yeah, I need some violence for the. And yeah, I don't like to repeat jokes, which is why I don't have any anymore. All right, so looks like HDMI is working here. We just need to set up, and there we go. Vladia, please tell us about Croy. Oh, no. No, don't click the cancel button. Is this it? Right, please welcome Vlad.
So this is a test. Okay, it's working. So hello, my name is Vladia. I'm from Apify, and today I'd like to tell you something about a library we've been developing there called Croy, which is a library for web scraping and web automation. So web scraping library, well, but you might ask, why would you need that? Why would you use that? Why not to use just a random HTTP library, maybe HTTPX, together with some HTML parser, maybe well-known Beautiful Soup, and you're right, you can do that, but, sorry? But the thing is that it won't scale, and for most cases it won't even work, because websites don't like being scraped, and they will try to make it hard as possible for you to do that, to get their data from their website programmatically, not via browser. And they use a bunch of techniques for that. And the thing is that dealing with all of these can be quite a challenge. So that's where Croy enters the town. And let me show you a simple example of how scraper written in Croy can look like. So a few basic concepts. We got a crawler class. In this case, we're going to use a Beautiful Soup crawler, which, as the name suggests, uses the Beautiful Soup parser under the hood together with some HTTP client. Then we got a request handler, which is a user-defined function where all the data extraction is happening, and you need to register it to your crawler. And then there is a crawling context, which is a specific class to the specific crawler that can provide you the information about the current page being scraped. There is data about the request, response, and in this case, the parsed soup object with the HTML of the website. And yeah, then we, in this example, we print the data, and we're gonna scrape the crawly.dev. So when you execute it, as you might expect, there is here's the output. We just extracted the title of the website. But even with Croy, you might get blocked. This is an example of IP address blocking, which can happen for numerous reasons. Maybe you have tried so many times and you've sent too much requests to the server from your single IP address, or maybe there are geographical restrictions or other reasons. And this is a well-known issue that has an easy solution, right? Use proxies. So here we updated the example of the previous example with a few lines of code. We added a proxy configuration, pass our connection strings to our proxies, and pass it to the crawler. That's it, no more changes, and it will use proxies. But even with proxies, of course, you might get blocked. As I showed at the beginning, there is a lot of mechanisms how to detect that you are not using browser. And one of other reasons could be the HTTP headers. And so here's an example of how headers from HTTPX look like by default. You can see that HTTPX even confessed that it is an HTTPX in the user agent. And here is the headers from a real browser, Chrome in this case. And you can see there's quite a difference in it. Actually, this is an easy thing to resolve, right? We can just replace the headers with some that looks like from a real browser, and we do this in Croy by default. But this might not be enough because of other techniques. For example, TLS fingerprinting, which is based on the fact that TLS handshakes from HTTP clients written in Python are different than the ones from browsers, because the Python implementation of HTTP clients uses a same standard library SSL, and it supports a different number of ciphers, signature algorithms, TLS extensions, and more than the browsers do. And all of these things can make you suspicious, and eventually you will get blocked. But even this thing has a solution, and we do not have to use a browser yet. There are HTTP clients that are called stealthy that tries to mimic the behavior of every browser, or to be more specific, the way how they establish connections. And one of that example is curl impersonate, which is a patched version of curl. And it has a port to Python, so we used it in Croy. We made a wrapper around it and implemented our HTTP client based on that. So here is an updated example of the previous one. We can just import the HTTP client and create a new instance and pass it to our crawler. And no more changes needed. It will use the proxies under the hood, same as examples before. In the request handler, we can still use beautiful soup as our parser. But well, now maybe you will be able to get the website you're trying to scrape. But you might find out that for obtaining the data you're trying to get, you will need to execute JavaScript. So now the question is, how can we do that from Python? And we can utilize a real browser. This will be much more resources intense than utilizing just HTTP clients, so this is a preferred option. But if we really need to execute JavaScript, this is an option. Actually, we don't have to write it from scratch. There are libraries for that. For example, Playwright by Microsoft. And again, it has a good port to Python, so we can utilize that. We can build on this. And in Croy, we wrote a Playwright crawler. So again, we're going to update our previous example. We're just going to replace our beautiful soup crawler with Playwright crawler, which will use the Playwright for making requests. It will operate a browser as we choose. And in the request handler, we have to make some changes, because now we do not have the context.soup object anymore, of course. We are using Playwright. We got there instead the context.page, which is a Playwright object. So we need to utilize that for extracting our data. And of course, again, the proxies will work. And one more thing, there's the headless mode, which is by default turned on, which is good for production. It means that you won't see the real browser window. But for the debugging purposes, development purposes, you can turn it off. And then if you execute your scraper, you will really see how the browser window is being opened and how Playwright navigates throughout it and getting your data. And there is much more features in Croy, but I got only 10 minutes, so that's all for today. Thank you for your attention. If you find this interesting, you can try Croy. It's on PyPI, or you can reach out to me after the talk, and we can talk about web scraping, Croy, and more. So thank you.
Thank you, Vladya. And I see the next speaker coming up. Hello, Darius. So this will be an action-packed talk. I guess there will be some violence involved as well. I think you can close it, yes. There we go. Other laptops. There's now a stand for the speaker's laptop. Yeah, just throw more hardware at it, right? All right, so this talk that's coming up is called Kill Gil. So anybody named Gil, you might want to be careful. Oh, well, what do you need? You're connected?
Yeah, connected.
All right. Yeah. All right, so this is the... Oh, this is the talk. All right. Take it away.
Can you hear me? Okay, great. Hello, I am Darek. I'm from Atacama, where I work as a software engineer. I'm really glad to be here. Today, I would like to talk about one of the most exciting new features that were added to CPython implementation, and that's an option to disable GIL. So, what is GIL? What we can achieve by disabling GIL, and how we can turn it off. So those are the topics that I would like to talk about in the next few minutes. Okay, so let's jump into it. What is GIL? GIL is an acronym for Global Interpret Lock, and it was added to CPython implementation like 30 years ago. The original purpose was to simplify concurrent programming, but unfortunately nowadays GIL is this infamous GIL that blocks, limits the concurrent programming, parallel programming in Python. And how? GIL, as I said, is a lock, and the lock sits on the interpret level. So only one thread at a time, which also means that only one core at a time, actually can interpret the bytecode, actually do something, be active. There is this myth that GIL somehow magically limits the whole bytecode interpretation only to one core, which is not true. It can execute the code in various cores, but unfortunately only one at a time. So this is another visual help. We have 3 threads. Let's say they can run on 3 cores. And as you can see, only one thread at a time, the green one, is active, is doing something, while the others have to wait to acquire the lock to actually get a chance to interpret the bytecode. So that's not great. What it basically means is that GIL synchronizes the parallel code base, your parallel execution. To give you also some hard proof and not just memes and animations, I run some tests. So I wrote this simple test where I have increment function, and this is like a kind of dummy representation for CPU-bound task, right? but you can replace it with any other CPU-bound task you can imagine. So this is a very simple function. It takes a counter and a number by which the counter should be incremented, right? And then I create the counter, and I increment the counter with 100 million. And on my machine, when I run this with single thread, without GIL, the execution time is around 6.5 seconds, right? That's not great. So some of you may have an idea to parallelize the execution, to improve the performance of this function. And as a matter of fact, we receive this suggestion quite often from our candidates in interviews, right? Atacama is hiring, by the way. So this is, for example, a screenshot that I took just a week ago. One of the candidates suggests, hey, let's run it in parallel. Let's create threads. Let's run it. OK, so let's try to do that. So I extended the example, and I added a few lines of code where I'm creating threads. My laptop has 10 CPU cores, so I'm creating 10 threads, and then I try to evenly distribute the load between the threads, right? So I would like to improve the performance of the function. But when I run it, it wasn't improved. It's basically the same, right? As I said, it's because of the GIL. The GIL synchronizes the execution. This piece of code, even though you might be familiar with threat models in different languages and so on, you might expect that it will run in parallel. But no, this runs basically synchronously. So that's not great. It's even worse, right? Because there was some overhead with the whole thread creation and so on. And there is another issue with this code, right? Because I'm a professional developer, I can see right away that I have a bug. There is a race condition, right? Multiple threads are accessing shared variable. We can encounter a race condition. So let's fix that. Because again, as I said, professional developer, senior, and so on. I will create lock, right? One of the ways how to solve race conditions is to create lock and lock the access to the shared variable, right? But when I run it now, the execution is really bad, right? So I had a simple task to improve the performance of the function. The function was beautiful, right? 5 lines of code. Everything was comprehensive. I added 10 lines of code because I wanted to improve the performance. But the performance got like 4 times worse. So bad. And I can see your faces. we don't have to use logs, and that's right. We can remove the whole access to the shared memory, right? We can create counter for each of those threads. Okay, so let's do that. And again, we couldn't beat the synchronous execution, because this is basically, this is synchronous execution. Okay, so GIL is a problem, right? We couldn't, with threads, improve the performance of the function, which would be totally normal in other language, right? You need to have that implicit knowledge that there is some kind of lock on the interpret level and so on. It's a mess. Okay, but now there is hope. There is a new CPython implementation without GIL, finally, after 30 years. So let's check that new implementation. Okay, so again, this is the same example. Now I'm running this single thread. Now I'm running this function with just single thread without GIL. And the execution is the same as it was with GIL, right? You don't look impressed, but believe me, this is a huge success, because over those 30 years, there were several attempts to remove GIL. But all of them failed, and they failed mainly because single-threaded execution suffered. And in this implementation, new version Python 3.13, we can run single-threaded code with the same performance as with GIL. Okay, but that's boring. Let's run it with multiple threads, right? This is what we've been waiting for 30 years. We can now run multiple threads in parallel. So the results are disaster. It's horrible. Okay, so the execution time is slightly better, but now when we run those threads in parallel, there is a much higher chance that we encounter race conditions. So every time you run this code, you get different counter value, right? It's a randomizer. There was a presentation about. So this is expensive randomizer, basically. So okay, so never mind. Let's fix the race condition issue. Maybe it will improve. So fasten your seatbelts. 3, 2, 1. It's bad. It's bad. It's really bad, right? What happened? So this is a early implementation of Python, CPython, without GIL. And obviously, logs are expensive, very expensive. So if you use logs, the execution time got like 2, 3 minutes or something to on increment counter. Okay, so last attempt. Multi-thread, without GIL, private access to the memory. Last chance to save this presentation from total disaster. And the execution time, finally, was much better. So we could solve this performance problem with threads like in any other language, which is great. Here are the numbers, as you can see, 10 threads in parallel with private access to the memory, best results. So to conclude it, concurrent modifications to share data does not scale well. And this is actually a quote from the author of the new Python implementation without GIL. This is his quote. So just bear this in mind. It's a strong shotgun, so don't shoot yourself in your foot. So yeah, that's it. And now how you can try it, because I encourage you to try it. It's really fun to play with it. You just need to be sure that you have that 13T, that T suffix, which means threading. It's not part of the standard Python release yet. It will be in the future. And you can check if you are running Python with GIL enabled or disabled by calling this isGIL enabled function. And to run your script in Python without GIL, just pass this environment variable Python GIL. And that's all from me. Thank you for your attention. And one last thing, we have a booth, Atacama booth back there. You are very welcome to join me there to discuss my presentation, Atacama AI, whatever you want. So thank you.
How many people can you handle in parallel at the booth? All right, thank you for the presentation. And now it's time for all the people who came for the pizza and had to listen to all the talks. The pizza should be ready, but before that, Moises will take up some more of your time with an announcement.
Well, it's an announcement about pizza. Okay. So the pizzas are labeled. We have some gluten-free options. We have some vegan options to try to accommodate everybody. There is a staircase you can use to access more space downstairs with a table. These rooms on the side here, you can also use their tables for the pizza. And if you are brave enough for the code, there's a door. You can go outside. There's some tables. If the door closes, you can't come back in. You'll have to go around the building. That's it. Pizza.
use Python to do that. Okay, please welcome Miro.
Lunch and some networking, we have to find a way how to survive until the next coffee break. So now please relax, lean back. You can close your eyes. And your breath is now going to slow down. And you imagine you are on a green meadow and there is an old wooden fence and there are some sheep jumping. You can close your eyes, there is nothing to see on the screen. And they are jumping over the fence, 1 sheep, 2 sheep. Your breath is slowing down. You feel that you are missing already some ideas. 3 sheep, 4 sheep. And there is a slow breeze in the countryside. 6 sheep, 7. We missed the 5th sheep. Wait, okay. Wake up, wake up. We missed 1 sheep. We have to start again. Okay, now lean back. Again, close your eyes. And we are going to count the sheep. So it's 0. No, it cannot start with 0. Okay, we will have to find a way how to keep track of the sheep. Of course, with Python, you can do it very easily, but this is completely wrong for 2 reasons. One reason, your eyes are closed. And with all this blue light from the white screen, you are not going to fall asleep. The second thing, you are in an isolated environment. No import of third-party libraries, you have only standard Python with you. This is better. But of course, this prints all the 10 sheep immediately, and you are not going to continue, and after 10 sheep, you are probably not going to fall asleep. This is a little bit better. Of course, I'm not now going to use a white screen because please, in presentations, never use black background. Our background, it is not legible. So now it's extraordinary for you, the white background. We can do this. Then we can count the sheep infinitely, but then this is going to be too fast. So let's use itertools. This will go forever. With IT count, itertools count, start at 1 and go on, but still it is too fast, so we have to make some break in between. And let's do a nice function out of it because you want, of course, to do also some other stuff at the same time. But this blocks your CPU for the whole time. So let's do it asynchronous. So this way you can also think about other things at the same time. But the problem with this is, well, it is always 1 sheep at a time. Let's go faster. Maybe we want to count the sheep faster. The IT count, we can tell a step. So you have a step of 2 sheep at the same time, and then they go much faster. So 1, 3, 5, 7. But it's not nice because usually you expect that the sheep jump in pairs. So how to start with 0? We don't want to start with 0. There is no 0 sheep. We want to start with 2 sheep. And so we have to put these 2 at the IT count at the beginning. And now we have nice numbering. This is to make it faster, but we also may want to make it a little bit slower. So for example, we are going to add not 1 sheep at every time. We are going to add 0.1 sheep every time. And this way, if every 10 seconds, you would get a whole sheep. No, never do that. Because when you are going to add too many floats after each other, 0.1 doesn't exist as a floating point number. So at some point, you will just have slices of sheep that will fall over, and you will never get the whole sheep. You don't want to harm that many sheep. You are never going to fall asleep. Let's use fractions. So this way, we are dividing the sheep by 10, and every one of them we are dividing by 10. So at the end, we receive always an entire sheep. We can do it even more advanced way. We can give the function 2 or 3 parameters. Multiply, it means how many sheep at the same time. Divide is to slow down, so how many parts of sheep at every time. And sleep is 1 second. You can slow it down or make it faster. This is actually beautiful, but it is always serial. There are pieces of sheep falling down behind the fence one after another. But we want maybe to parallelize that. And that way we can create actually something that batches. So there is this IT batched since some recent version of Python that allows you to have several pieces of sheep falling over the fence at the same time. This should be actually the ultimate that we need. And well, let's keep the things more human. Let's keep whole sheep. This is fine. So we have 1, 2, 3 sheep at the same time. Then, okay, the problem here is that you are counting the sheep sequentially. 1, 2, 3, 4, and so on. If you fall asleep and you count the sheep, and there is someone sitting next to you, at every moment they can calculate how long you were counting sheep. So if they hear 67, 68, 69, so they know that you are falling asleep since over a minute. Let's get some randomness over there. But how can you do it randomly? You could take a big amount, a list of integers, and then randomly select from them. But what amount of integers do you want to take? Do you want to take 10 integers? That's too little. You are not going to fall asleep after 10 integers. You want to take 1 million, 1 billion. But 1 billion of integers in the memory of Python, that takes too much memory. So the IT count is actually a very good tool because it generates the sheep sequentially without any memory consumption. But if you want to do it randomly, you have to choose from some part or some amount of sheep at the beginning. You could tell also, okay, I'm going to take the first 100 sheep. I'm going to select randomly 100 times. Then I take another 100 sheep. But then you have this jump from 100 to another 100, and that's not so nice. So that's why we can do actually something like this. We can create a buffer of 20 or 200 sheep, and every time we get one random sheep out of it, and we add a new one. So you will have some randomness in there. But still, you are still vulnerable to the German tank problem. This is something that the Allies used during the World War II when they calculated how many tanks did the German army produce out of the number of the serial number that was on the tank. So every tank had a serial number, and if I see one tank and it has the number 3, I can expect that totally there are 5 of them. If I see 3 tanks and they are numbered 1 to 3, very probably I have seen all 3 tanks. If I take 2 tanks and they are numbered 1 and 10, probably it is the amount of tanks is 14. And even if I have 9 and 10, then it is 14. Because if you take the maximum number, and with this formula, you can actually calculate what is approximately the whole number of all tanks. This means that your procedure is still vulnerable against this because you are adding sequentially to your buffer the sheep. So you have to find some solution. We said that until now we used everything in English, but there are also other languages. So probably if you want to sing also in some other languages, you will see that you are not only formatting the numbers that are also sometimes tricky because we count the thousands and we divide the thousands from the other 3 zeros with a comma or point or nothing. But for example, the Chinese, they group the numbers by 4 digits. So you have to take that also into account. In all these languages, whether you count 1 or more sheep, it is always the same word. So in English, in Hungarian, birka. If you say only sheep, like a plural sheep, in Hungarian it's birkak. But if you take the number before that, it keeps the singular. The same in Turkish. In Chinese, sheep is yang. But if you want to tell 1 sheep, then you have to say yizhe yang. That the zhe is also something that counts the objects. And then you have liang, zhe yang, and so on. In Swedish, that's et for tvefar. In Esperanto, no, this is not Esperanto, this is Basque. You have to, don't forget that in Basque, the number 1 comes after the sheep, so ardibat, and all the others, they come before. So, in some other languages, it is more complicated because you have, for 2 and more, you have a plural. So you also have to take this into account. For example, in German, Spanish, Italian, you hear that, schaf, schaf, and so on. But in French, they add an S and they pronounce it the same way. It's mouton, mouton, un mouton, deux moutons. There is no difference. And also in some other languages, and then come the Slavic languages, and I suppose that there are some non-Czech speakers here. In Bulgarian, it's a Slavic language, but they still have a normal concept of ovca, ovce, so plural, that's ovce. In Polish and Slovak and other languages, they count up to 4, it's plural, but from 5 onwards, it's genitive. So you don't say 2, 3, 4 ovce, you say 5, 5 oviec. In Czech, this is randomly in this case that the 2, 3, 4 is the same word as 1, but 5 is different. You have to understand that. It is like that. And Slovenian has dual, so it means that they have 2 is 1 ovci, 2 ovci, and then 3, 4 ovce, and then ovc like other Slavic languages except for Bulgarian. So this is it. And now imagine that also one thing that I will now let as an exercise to the reader. If you want to know whether your amount of sheep is going to fit into a nice rectangle, it means you don't want to have your sheep as a prime number. There is one library in standard Python that allows you to calculate that, and that's regular expressions, that RE. And this will allow you to that. And with these words, now we are going to return to the state of awakeness. You can open your eyes and return to the program. Thank you very much.
Thank you very much, Miro, for a very relaxing talk. Next up, we have Martina. And oh, that's another two-person setup. And this will be about counting genes.
Does it work now? Yeah, sounds better.
There we go. All right, stage is yours, Martina.
Okay. Ladies and gentlemen, welcome to my presentation. My name is Martina Zátopková, and today I will give you a very brief and very simplified overview of how we scientists read genomes. So, genome is a collection of DNA, a collection of genetic information stored in organism DNA. And DNA is a very famous molecule that it contains of two strains that are connected to each other with so-called bases that we mark with letters A, T, C, G. A always binds to T, C always binds to G. And later in this presentation, I will talk about base pairs. So these pairs, so it's the amount of these pairs in the DNA. Just remember that. The main role of DNA is to be a recipe for creating of proteins. This is done via RNA according to code of 3 letters. And in this presentation, we can see only 3 peptides in the polypeptide chain. But in reality, these proteins have 50 to 34,000 peptides. So you can imagine as a necklace in a rather straight shape than a circular. And each bead in this necklace has its physical and chemical properties. And these properties further predict 3D structure of the resulting protein. The 3D structure is very important because it predicts the protein's biological function, and it also predicts whether it will be able to bind to proteins with complementary shape, and then do the biological role. Now imagine that some letters here in the recipe changes, or some letters even can be gained or taken out. This can result in incorporating of different peptide, or it can even shift the time frame. So when you see that if you have AUC here, it can be changed to UCU. And then you have very different protein. It can be corrupted and you have a problem, or doesn't even have to be. It can result, for example, for a different color of eyes, or it can also result in serious disease. Yeah, so when we go to read the genome, at first we need to take samples. From human, we usually take blood or buccal swab. And we lyse the cells, then we do some protein removal, then we pour this mixture into specialized tubes that have columns that are able to bind DNA. So DNA is bound there, and then we use other solutions to wash. This tube is you pipette the solution there, and then you put it into centrifuge, and you can perform this step several times to make the DNA really clear, and then you make a illusion that disrupts disrupts connections between the DNA and the membrane, and you are gaining the DNA. DNA in human cells have around 2 meters. We have several technologies that are able to read DNA, but none of them is able to read it as a whole. Today I will tell you a bit about Illumina and Oxford Nanopore, but remember there are more of them. So for Illumina, we really need to cut the DNA to little pieces, usually 100 to 500 base pairs long. And then it can read these little inserts, even from one or both sides. Usually, the length of these reads is 100 base pairs, and maximum is 300. On the other hand, Oxford Nanopore works on the principle that there is a desk with nanopores, like pores, and DNA is pulled through the pore, while the pore is measuring voltage. And this voltage then provides you information about the sequence structure. This is a resulting FastQ file from the Illumina analysis. For each read, there are 4 rows. There is a sequence name, sequence itself, then there is an empty space, and then there is information about quality of each base in the sequence. So the first part of the analysis is usually the quality check. Now, when you have a collection of about 100 long reads, you can even create a sequence de novo by searching for overlaps in those short reads. And this is usually done for new organisms. And for human, this analysis was already previously done. So if we study human, we can use the universal reference sequence, which is used in a like huge majority of other projects, and then we take the reads and map them to it. Let's imagine the reference sequence is just here, and you are mapping the reads there with very cool Burrows-Wheeler algorithm. And from this figure, you can see that the change is here, so there will be some variant here, probably also here. Then you can see something like this. It probably will be artifact or what. So a result of this analysis is a list of positions with probable variants. Now, in reality, it's not that easy. You have the reference sequence, and then you have some kind of coverage of the reads, and some amount of reference basis in the reads, and some amount of alternative. And you need to decide and make basically a threshold of what you want to take as a variant, and you want to work with this, and what you consider artifact. So in the end, you always end up with some amount of false positives and false negatives, and you need to really distinguish what you want to consider for other analysis. What helps us with this is, for example, annotation of these variants from public databases. There is information from previous investigation and about protein structure and possible function impact. Maybe you remember the first slide where I talked about it. Population of such a variant in a frequency and other interesting and very, very useful information. When you annotate the mutations, you can filter those mutations according to what you wish to study. Then you can do some cool visualization. You can take a look and interpret what is the meaning of the results you find. And if you think you found some cool mutation, for example, some mutation that can cause a resistance to drugs, you can also use other methods than the next generation sequencing I told you before. It's like Sanger sequencing, which is much more precise, but is not possible to do it massively for a whole genome. So if you cherry pick interesting points, then you can do even this testing. And then you proceed. Then you can proceed in testing on cell lines or in organisms. And if you have a collection of well-studied and prepared and like confirmed mutations, you can also use this information for precision medicine. So the role of bioinformatician in genome analysis is mostly writing of pipelines that are able to analyze the data. You can very often use existing programs. You need to be oriented in what kind of programs exist and how to set them, and you also write a lot of your own code for analysis that you wish to perform then. For the pipeline creating, we have cool tools like SnakeMake, Whittle, or Nextflow. And then when you have the results, you can do various of other analysis. So as a bioinformatician, you need to know a bit of computer science, chemistry, biochemistry, biology, statistics, mathematics, engineering, and then you can do some cool stuff. Okay, I'm almost on time. Thank you very much for your attention.
Cool stuff, and thank you, Martina. Next up, Maciej, are you here? There you are. All right. So, how long will it take to set up this computer? Any bets? Oh, this is a 3-person setup. Okay. So, how many engineers does it take to plug in an HDMI cable? I don't count, I'm just commenting. All right, meanwhile, we're getting a fix to the fun mode. All right. So, anybody know that mountain? No, that's already gone. You can use that mic. Perfect. Ready to go? Stage is yours.
Yeah, does it work? Okay, so yeah, my talk is about optimizing LLM performance using Triton. Closer. Closer, okay. Yeah, so many of you might be familiar with LLMs, and like there has been a steady rise in using AI models for basically everything. And how can we optimize them? Yeah, so first something about me. I'm a student here in Brno at University of Technology, where I study machine learning and artificial intelligence, as everyone does now. And I currently work at Hugging Face, where I optimize distributed training on multiple GPUs. And I work at libraries such as Accelerate or Transformers, which you might know. Okay, so first thing. It will be about optimizing with Triton. So what is Triton? Triton is a language by OpenAI, which is open source, which is surprising for something by OpenAI. And yeah, even the compiler is open source, and it's built on top of the LLVM toolkit. This allows it to be portable to multiple GPU types, such as AMD or NVIDIA or Intel accelerators. And it's designed heavily for AI workflows, so it utilizes a LLVM for lowering the code to linear algebra. So then it gets lowered into the machine code, etc. And that is really portable and easy to use. So here you can see like a graph that if you have a problem that you want to optimize, what would you choose? Like, if you're deranged on either side of the scale, you can use math to optimize the algorithmic solution, or you can use the PTX, which is assembly for GPUs. And yeah, that's not really fun. In PyTorch or CUDA, in CUDA you will get a segmentation fault most of the time, and in PyTorch, good luck optimizing that. And in the middle of that, there's Triton, which you can use, and it simplifies the GPU programming. So why would you do that? Like, GPUs are expensive, and we as people are poor. So for example, running on 8100 GPUs for 1 hour costs you around $20 on use most of the cloud providers. So you want to save that money. And Triton makes it simple and effective. It is a lot less headache than CUDA, because in CUDA, if any of you did someone of you write something in CUDA? I didn't think so, yeah. So you would have to manage all of the threads, all of the pointers, and it's big headache and a lot of mess. So yeah, and what does it give me? Like, it saves me money. That's the most important part. It saves our planet a bit because we run the GPUs less and it's more effective. And it also, you also get the satisfaction that your kernel is faster than PyTorch, which is actually pretty easy and simple to do, as we will see next. So the sample problem that I will be optimizing today is KL divergence. It's a commonly used loss in LLM training, used in knowledge distillation, where the student model learns from the teacher model. It basically compares two distributions, and the result is the information loss between those two distributions. As you can see down there, that's the formula. You don't have to understand that. I don't either. And you can see in PyTorch, it's really easy to implement. Like, you just call a function that does it for you. How to do it in Triton? That's a bit more difficult, because in Triton, you don't really have KL divergence. So Triton does work in GPUs, so you take in the ID of the thread that you're working with to know which data you'll be loading. That's the PID. Then you calculate some stuff, load the data, and then the data, you will execute like the logarithms, like the formula. That doesn't really matter. And then you'll store the output to the pointer. As you might notice, Triton does use pointers. You might be familiar with pointers from your C classes, etc. And they're a headache to work with. So how does this integrate with Python, where pointers don't actually exist? So actually, in Python, exactly in PyTorch, pointers do exist. Every tensor in PyTorch has an underlying pointer, and it actually works very well with Triton. So you can just pass in the data into the function as you would in a classical Python function, which you can see on the line 9. And you call it with the torch tensors, which are P and Q, and the output tensor, which is the output. And you can see that it uses actually the bracket and grid, which is a configuration on how many threads to launch on the GPU, which is a detail that I'm not going to go into. But that's something that you can optimize as well. And with this, you can actually plug it into Torch Autograd engine, some of you might be familiar with. So like PyTorch, when you train neural networks, you do forward, which calculates the outputs, and you do backward, which calculates the derivatives. So with this, you can define your own operator built on top of Triton that will be incorporated in the Autograd engine, and you can call it, and backward would work just fine, as you can see in the bottom. So some benchmarks, like this is a really simple example. It's not the example that I wrote, because this is a production-ready version of KL divergence that I wrote for a project called Liger kernel. You can see the benchmarks that it's faster. It takes in less memory. You can see the x-axis is actually batch time sequence length. It should be batch time sequence length vocab size. So this is pretty small. In current LLMs, this could grow up to some millions. And in those, like, it scales actually quite linearly. And in those cases, you will save a lot of memory and a lot of time. And this is a simple example. So the question you may ask yourself is, do I have to write my whole LLM in Triton, like operator by operator? No, you don't. Like, there are a lot of cool problems, a lot of cool projects that actually do it for you and define the operators that are that take most of the time based on profiling most of the memory and optimizing them. Some of them are like Liger kernel or Unsolved AI, which specialize the first one on training and the second one on inference. These actually do integrate with like the existing ecosystem, such as PyTorch or Hugging Face, Transformers, Trainer, whatever. And how would you use them? It's really simple. This is an example on how would you replace your classical LLM in Hugging Face Transformers library with the optimized one from Liger kernel. The model that I chose is 8 billion Llama 3. And this is like how would you basically just replace it. And the rest of the training inference logic stays the same, so you don't have to change anything in that case. And it also integrates with rest of the ecosystem, such as the trainer or whatever inference provider you might use. So Liger kernel basically monkey patches the model and replaces some of the layers and some of the operations with optimized ones, which like fuse some kernels so you get less overhead, like better memory accesses and freeing the memory that isn't needed anymore. And it makes it faster and a lot more effective, which you can see here. This is a benchmark that I ran. It's on 8 billion Llama 3 as before. It's on 8 H100 GPUs. So just a small info, like 1 hour of these 8 GPUs would cost you around $20. So optimizing it is quite nice. And no one will use only 8 of them. These are the graphs that will show you like the allocated memory and reserved memory by PyTorch. And as you can see, like the first 3 rows are in Triton. There's actually a typo. But as you can see, like the last one, which is the default Hugging Face, does consume a lot more memory. And it's on the 32 batch size, and increasing the batch size would actually result in out of memory error on Hugging Face, not in Liger. And the last thing that you want to ask maybe is it faster? Like this is a benchmark of tokens per second. Again, all of the kernels that were in Triton are a lot faster, like around 20% faster-ish than Hugging Face. So that would result in $4 of saved money per 1 hour, which is quite a lot. And yeah, I thank you for your attention.
Thank you, Maciej. And now we should have a really quick setup, because sometimes the speakers pair up and just plug in one computer for 2 talks. So Tim here is all ready now. Stage is yours.
Both hands if this microphone is working. Awesome. So now keep them raised, and shake your left hand so you remember which one is your left hand. And put that hand down if you've ever generated a JWT token from JSON. Okay. If you have generated a JWT token from JSON, and so now you have your right hand up only, hopefully. No, you guys haven't. Great. So now shake your right hand and put that down if you've ever used a topic-based message broker like MQTT or Kafka. No? Okay. So it seems like there's going to be a lot of new topics today. So I'll start with the fact that last month I had a workshop with my company. All of us came to my house and we discussed our product. And of course, at lunch we got hungry, so we had to order pizza. And my boss went online, and he selected the pizza that we wanted. And all of a sudden, we saw on his screen a map with a little dot showing where the courier was, taking the pizza to us. And that map was updating live. If you think about a typical web server setup like this, you have the browser, it sends an HTTP request to the load balancer, and then the load balancer routes that request to the server using something like Kubernetes to orchestrate all of the different containers. This is pretty impossible, because how does the web server send information to the browser, right? the browser can make a request. Is it the browser asking the server every 5 seconds, has the courier moved yet? Has the courier moved yet? Has the courier moved yet? I know I did that when I was a kid. I used to order things online and refresh the page over and over again to see if my order was ready. But there's a better way of doing that, which is to have it so that the server can send a message to the browser. So if you Google, how do I send a message to the browser, you'll get this list of strategies for doing so. You can do long polling, server-side events, WebSockets, and none of these strategies are possible with this architecture because in, for example, Kubernetes, these server containers, they're ephemeral. And if you were to let Kubernetes kill the server at any time, that would mean that the connection, the WebSocket connection, or the long poll, or the web server-side events would get lost. So all of these strategies, despite that Google says that they're possible and they're the correct solution, are impossible. And I spend a lot of time trying to find a solution that actually works. And what I came up with is that topic-based message brokers are pretty useful for this. So a topic-based message broker works in that you have a message and you write on the message an address where you want to send that message. And so if you imagine we have the sender, which is the web server. We have EMQX, which is an MQTT message broker. And you send the message to this topic, foo bar. And then you have the web browser, which subscribes to that topic and receives that message. So if we imagine that the topic is users, user1, GPS, that is the GPS coordinates of the courier that we are interested in. The sender is the web server. The sender knows that the courier has moved. It sends this message to EMQX, and then EMQX sends it on to the web browser. So here's a full architectural example. So the courier is constantly sending their GPS coordinates to the load balancer via an HTTP request. The load balancer then sends those GPS coordinates to the server. The server then uses the MQTT protocol to send that message to EMQX, and then EMQX is managing a WebSocket connection. An EMQX, it's not running as an ephemeral container. An EMQX server is something like Postgres. It's really stable deployment. And EMQX then sends over WebSockets to the browser those new GPS coordinates. This is a little bit different than a normal envelope with an address on it, in that the broker can actually duplicate the messages. So if you have 3 web browser windows all subscribe to the same topic, then EMQX will duplicate those messages and send it out kind of multicast style. So this is great, but it's actually completely broken because in MQTT, anyone can subscribe to any topic. So it would be completely insecure if we were to have it so that every web browser were to connect to the general MQTT broker and subscribe to any topic they wanted. There would be literally no privacy whatsoever. So that would suck. So EMQX has a solution for that. And that is the combination of JWT web tokens and mount points. So what is a JWT web token? A JWT web token is an encrypted piece of JSON that only the web server and EMQX understand, but the browser cannot generate and cannot falsify. And a mount point is a mount point like in, it's like giving the web browser or the client only access to a subfolder in the tree of topics. If you look here, you see that this is like as if there's a folder named foo. And the mount point could be foo, and then the subscribers that were on that mount point could only see the topics that were in the folder foo. So in EMQX, we can set this up by saying that we want to get the mount point from the JSON web token. We can launch EMQX like this, and then we need to generate a JSON web token that contains a client attribute that is the mount point. So on the server side, we can generate a JSON web token that has a mount point that points to the specific user, and give that JSON web token to the web browser. And then the web browser can attach to MQTT and only see the messages that come into that web mount point, but they don't see anything else. So therefore, the privacy is maintained. Now I'll go ahead and show you how this actually looks. I hope that what? I don't know how to use this windowing system. I happen to use Sway normally, but Sway doesn't like to play nice with multi-window setups. Yeah, so here we have MQTT UI. And MQTT UI is connected as user 1 using a JWT web token that has the mount point users, user 1, attached to it. So I can see any messages that are coming into the mount point users, user 1 here. If I go over here and send a message as user admin, and user admin, I've generated a JWT web token where the mount point is blank so that it can see all of the topics and publish to all of the topics in the broker. I can then go ahead and publish a message to users, user 1 GPS. And you see that the message shows up immediately in the MQTT UI. And this is over the WebSocket protocol. You see that there's this WS down here, right? So this could be used in the web browser as well to get that message. It's also possible for user 1 to talk to things in its own namespace or mount point. You see here, we're publishing to the topic GPS. Here, we're talking to the topic users, user 1 GPS. And you see that the message gets received immediately. So this is like the general concept of how to do it. You'll notice that we were using WS, that is WebSockets. And if you remember previously, Lumir had a talk on randomness, and he mentioned that everything has an S at the end. Well, you actually want the WSS. So EMQX does support WSS, but I think that that's for masochists to set up your own SSL keys or whatever, so I just use caddy in front of EMQX to encrypt everything. And of course, you can do all this with Python, and the best library that I've found for using MQTT with Python is called Paho MQTT. I'm not going to demo that here, but what you can do is you can find a fully working example of the demo that I did present on my GitHub.
Thank you. That was pretty fast for a talk here.
Sorry.
No, it's fine, it's fine. That means you're gifting time to the next speaker. Do we have Amelia?
She has a recording.
Oh, she has a recording. Well, that's a surprise for me. All right, so we'll clear the stage and let Amelia introduce herself.
Hello. Sadly, I cannot be here with you today, but I would still like to show my presentation to you and share my message. Today we will talk about diversity, neurodiversity. Well, this is a term which describes diversity of our brains. There can be different, various operating systems, and it's slightly similar in case of our brains, our neural systems. There are so-called developmental disorders such as ADHD or autism, on which I will focus today. But scientists tend to think more and more that maybe this is just natural diversity of people, maybe this is not a disorder. And why should everyone know that word and be aware of that? Well, there are all those stereotypes about autism and ADHD. For example, people think that it only concerns boys, and it's often linked to children, and it's so much broader. But let me illustrate it with a story. This is Beautiful Brain. Well, story of this girl. When she was a baby, her parents could already notice that she was kind of special. For example, she was very sensitive and quite anxious, but it was quite okay up until school. When she went to school, she could not interact with other children. She did not know how to play with them. She did not seek contact. And she was also still quite anxious. She was very overstimulated by the school environment. And she went to a psychologist. Her mom wanted to check up on her. Why is that like this? But the psychologist just said, don't waste my time. This child has good grades and is well behaved and is very quiet. So there cannot be any problem. You see, like lack of social interactions is not an issue for me. So this girl was convinced from the beginning that, well, there is everything good with her. And if she thinks otherwise, she must be just somehow mistaken, broken. The last years of school were really difficult for her. She's a perfectionist. So the anxiety really reached a level. And university time brought some kind of more relaxed. She was not so overstimulated anymore because there were no loud bells, no crowds of children. University environment was really nice, really good to her. And then she could just excel in her favorite topic and meet some people in scientific clubs, some people with the same interests. And finally, she could find common language with these people. Then she went to work in IT. She started pursuing specialist career path, which was great for her because she loves to learn new things and meticulously investigate some concepts, for example. But she's been having issues with this 40-hour work week. Well, 8 hours per day, and you just have to execute all the tasks with kind of like similar pace. But she's not like that. She works in intensive hyper focuses. She can accomplish a lot. She can accomplish like a task, finish a task in 2 hours that with normal pace maybe would take 4 or 6. But then she's completely drained of energy and she just needs a very, very long break. And managers do not always understand it. They often have issues with that. But as she's very productive and a good employee, they just don't say much. And then pandemic comes. And of course, pandemic is horrible, but brings one great thing, remote work, which she loves. She can finally manage her daily schedule better. She can take breaks whenever she wants. And what counts are the results, not the hours during which she sits on the chair. And she still thinks that there is something wrong. Something about her, she doesn't fit the world well. And she starts hearing some podcasts, YouTube videos, and others about autism in women. First, she's very skeptical. Autism, these are small boys who don't even speak. But she reads more, and she ends up in some Facebook group for women with autism. And she's like, wow, this is me. But she has this imposter syndrome. So he goes to a place which diagnoses her, just professional place where she gets this official one. And finally, everything falls into place. This being strange her whole life is just having different neurotype, different facial expression, communication patterns, diving into special interests, and spending all the time doing this, hyper-focusing on tasks, and then being drained of energy. Overstimulation because of sounds, lights, traveling in a tram or bus to work. All of this is kind of explained. And I would not exaggerate if I said that this is the start of a new life at the age of 30. And you might maybe guess or not that this story is about me. And I would like to share it because I think it's worth looking for answers. And improving your life and diagnosis can help you a lot. And the problem is This is a bold statement, and some people might be angry and saying that, but I believe we are in sort of a stone age of psychiatry, psychology, of science on autism and ADHD in general. Because this is very young science, and I'm not blaming anyone. We are just looking for answers still. Autism has been somehow defined like 100 years ago, ADHD a bit earlier, but still, like the official definitions are younger than 100 years, I would say. And we still have so many questions, like what is the genetic background? Can you actually scan a brain and detect autism? No, you cannot. We don't have such tools. We are still exploring that. And there are more answers to come. Also, this aspect of female spectrum, it's either autism or ADHD. It has not been researched much. It started only recently. And, well, it manifests differently in women. And we don't even really know the numbers. I mean, there are various ones, like depending on the country, region, method. So we are still not even 100% sure how many people are autistic or have ADHD in standard population. We have some close numbers. And IT industry, well, here I need to mention something called geek syndrome. You can Google it to read more, but basically scientists at some point noticed that in families from the STEM industry, like engineering or science, there are more children with autism. And there is a hypothesis, or actually an observed trend, that autistic people might pick jobs which require some kind of analytical tasks, some kind of meticulous work, for example, with code, and it often corresponds with their special interests. And once you learn about your diagnosis or about your colleague's diagnosis, you can express your needs, or you can better understand this person's needs. And sometimes not a lot is needed to, for example, adapt your workspace. Or you can just ask for work from home. I know it's not always possible, but I think managers should realize that for some people, this is just an improvement to their life and to their work. And we need to understand this context, that this is not only some kind of wish. This is a real need that has some real background. And, well, you can also stop something which is called masking, just pretending to be normal or just pretending to be neurotypical, as you learn after you get diagnosis. You just accept that you're a little different. You might look for your neurotype, so people who are similar to you, and you accept that you're yourself. And everyone is different, and this is good. And autism is also a spectrum. It's not linear. So autistic people are very different from each other. It's not like you can look at a person and know they are autistic. Please remember about that. And thank you. My presentation ends here, but I hope your experience with neurodiversity is only about to begin. And I'm very happy I could share this story. And if you have any questions or remarks, you can find contact under this page. Thank you so much.
Thank you, Emilia. And now, who's been following the program? Who knows what's next? Coffee. You're all still sitting? I'm not going to tell you anything interesting here. Just go get coffee.
So, who of you likes writing documentation? Oh, there are some, not many. Well, even if you like it, I write here that nobody likes writing it. I'm obviously wrong, but there are still some problems with the documentation. First, it is inaccurate the moment you write it. It is incomplete. It is inconsistent because the more documentation you write, the more likely it is that you make a mistake or we just change a concept. And of course, examples are not a very strong part of the documentation. So I'm not going to give you a tip for everything. I'll focus on the first flaw of documentation, and that is inaccuracy. That documentation is sometimes wrong because it is written at a different time than the code, or it is changed at the different intervals. The key idea is to automate writing documentation. And I will give you a practical example and tips how to do it. So let's start with an example. This is an example from the car sharing business, which is my hobby project. So car sharing is something like automated contactless rental. So you can rent a car for, let's say, in this example, for 2.5 hours. And of course, you would like to know how much it costs. So it will give you a calculator that you can show on the screen, and it depending on the number of kilometers, because in car sharing, you typically pay for the time spent, and for the kilometers driven, it will give you some price. So this calculator is a software component with an impact on the user behavior. So you would like to have it documented. How do you do it? Step 1. Start with the examples. There is a whole methodology for it called specification by example. Shortly, you have to choose key examples. So in our case, for example, and you start your reservation at 7 o'clock, you finish at noon, you drive 40 kilometers, you pay some euro. Second key example, different time. Third key example, different distance. Not that important what the examples are, just talk about them to your business. People talk about them with your customers. Have representative set of examples. Step 2, automate the examples. You need to do it anyway, because in order to make sure that your algorithm is right, you need to write tests for it. We write tests, guys, yeah? Ideally, unit tests. So unit test looks like something like, you create a reservation that represents my example from 7 to 12, driving 40 kilometers. And then I do my stuff that I usually do for testing. So I run the calculator and assert that the result is right. More or less, all the tests here have the same structure. I could even parameterize them, but I didn't do it for this example, just to make sure that there are multiple examples, multiple test cases, and each of them represents one example. Step 3. Collect information about the test cases. So in this example, for example, before you start the test cases in the setup class, if you use Python, Python unit test, you initialize something like a context. Why I use the name context, I will explain in a minute. That I will use to collect information about the example. So my test case actually looks like create a reservation, do something, and then I store information about the example in the context, which is essentially a dictionary for now. Yeah? And how many test cases I have, then that many examples I store in the context. Step 4, now comes the trick. I take the context, which I have stored during the test case execution, and I write it to a file. In this case, I use a Django templating service and just render it to a markdown file that will show the examples in a table. Yeah? Go back one slide because I forgot to say one thing. Please notice that I fill the example only after the assert section. So after I am sure that the test case passed. So the document, I know that the algorithm works as I
designed it to work, and then I just document it with this extra statement. So I document it, write it to a file, and it generates something like this. It generates a documentation file. In this case, it is a markdown file, but it can be actually anything. It can be an HTML file, nicely formatted. It can be a YAML file that you will feed then to your documentation system. And you can directly take it and include it in your documentation, either a technical documentation for other programmers or to a user documentation for your users and customers. So to summarize, the procedure is start with the examples, find the key examples, discussing with your users what is important for them, what covers all the use cases. Automate the examples as unit tests. You need to do it anyway to make sure that your algorithm is working right. Let the test cases collect the data. After they pass, then they just do one extra step of storing the input and output of the test case to some data structure of your choice. And at the end of the test case run, store it as an HTML file or in any human-readable form. By doing this, you solve most of these problems. So the documentation is always accurate because you know it, that your test case passed and generated the documentation. Your documentation is probably complete. If you are not complete, if they are not complete, it means that some of the test cases are missing and you should improve your coverage anyway. So if you do it, you'll also make your documentation more complete. It's consistent because all the test cases behave in the same way. All of them generate the same part of the documentation. It's full of examples. It's essentially only examples. Of course, you could generate not only the examples, but also some text of the documentation, but I will leave you up to your fantasy to do it. And instead of writing documentation, you just turn your job from this to coding. And this is the activity that we all love. So that's it. Thank you. If you're interested, connect with me on LinkedIn or drop me a question here. Ask me. Thank you.
Thank you very much, Robert. And now, do we have Barbara? Oh, there you are. Hello. Welcome on stage. And what's your setup? Are you using the default, the computer stand? That's also a computer. All right, so this talk will be about IT managers and communities in hiring. Bridging the gap. All right, I think we're... all right. So there's a few PDF files, and one of them is correct. Where's the what? HDMI is already in. Is that the right clicker? Okay. All right. Please welcome Barbara on stage.
Hello. Hello, I hope this does work here. So my name is Barbara Holušová. I am the engineering manager in Red Hat. And as I used to be active in the IT community in Pylidis Ostrava, I was asked to elaborate a bit more about what the IT communities can bring to their members to become the successful candidates, the ones that are chosen by IT hiring managers, and what is the benefit of IT hiring managers in cooperating with those IT communities. So I will focus in this talk to both of these views from the view of the IT manager and for the view from the IT communities, what they can do to help their members to grow and find new positions, new jobs, and also on the point of view from those members and candidates in hiring interviews. So first I will focus why it makes sense for an IT manager to be part of the IT communities and to be active there. Well, firstly, it's good to realize that in the IT communities, there are people like you. And these people are usually very passionate, engaged. These are those who are willing to spend their Saturday somewhere else, bring their time and effort, and to do something beyond their usual responsibilities and work. These people are willing to stay updated with the new technologies. They are willing to learn the new trends. They are willing to stay in touch with what's going on in the IT world and so on. And they are willing to share this knowledge with others as well. So this is something what we should see in our candidates when we are doing the hiring later on as well. And from the point of view of IT manager, it's good to realize that the interview is mostly 1 hour, 2 hours. There's not much chance to reveal more about the personality of the candidate and so on. So the IT communities, it brings us also a chance to get to learn these people more, to get to know about their passions, about how they collaborate, how they are able to make some leadership roles, what they do, how they communicate, and so on. So this actually gives the advantage for the hiring manager then. There's a concept called skills-based hiring, or also the recruiters, they call it soft skills over hard skills. And this is something I would totally vote for. I will say, as there was a talk about Atacama hiring and so on, it's not only Atacama. Everyone, every company, every hiring manager wants to hire the best talent. And now, what is it actually, best talent? Is it someone who has PhD, who has been at the university for a long time, but who has been only at the university with a lot of technical knowledge, for instance? Is it someone who has 10 years, 15 years of experience in some field, but actually is a professional in some area, but is not really willing to learn a new programming language, is not willing to learn about clouds and stuff like that? Or is it someone who actually wants to do something more, wants to change the career, is willing to spend their Saturdays, weekends, whatever, nights in learning something new, is willing to learn something new also in their working hours, is simply wanting to grow? So this is something we should be able to see, and we should rather focus on the candidate's skills and abilities than the formal education or background or something like that. So more it's about focusing on what that candidate can do rather than what they have been. Focusing on the future, also from the point of the company and the business needs from the company and ability to grow, than something what has been in the past, because it's actually no promise. What has been in the past, it's not such a promise that it will be like that in the future as well. And this concept then opens the hiring also to some non-traditional candidates. Career switchers, typically it can be women after maternity leave that are very often part of these IT communities like PyLadies and stuff like that. And also this opens the position also for self-taught individuals. So it's more about for these to showcase the potential, what they can bring to the employer, what they can bring to the job, to the hiring manager, to the company. And it's about the ability to showcase it in the CV, in the interview, to sell it properly. So now going to the other part about how IT communities can prepare their members for those jobs. So one of the first thing you would think about is to help the members to gain practical experience. Mostly it is the technical knowledge sharing, technical growth and stuff like that. It can be a possibility to gain because these people usually don't have any practical experience. They want to usually to step into the IT world. And it's not easy on the CV to go there without any line about, okay, I have been working as IT admin, whatever. So how we can help them? For instance, it can be help to let them collaborate on some real world projects that can be then later on added to their portfolios or CVs or whatever. And also we can lead them to work in open source, towards open source contributions. And all of this increases their visibility and practical experience, and not only that, but also increases their self-awareness, self-confidence, that they know that they can do it, and it is then visible in the interviews. The other part is upskilling, and I would add here upskilling in alignment with hiring trends. We can, of course, upskill, for instance, in COBOL, or we can upskill in Python, and it's a different story. For those candidates, what kind of positions it then opens. And the upskilling can have several forms. For instance, in PyLadies Ostrava, there is a program for mentorship. This is an online program where the people who want to be mentored, the mentees, can just let us know what that they would like to grow, can send that some justification. They are then being matched with the mentor, and they have documentation. They have someone who guides them, who shows them what to do. Other forms are told like this one. This is also a way how the candidates and members of IT communities can gain some experience. Or it can be peer learning sessions, peer coding, certifications, stuff like that. And now it shouldn't be only about technical upskilling. It should be also about increasing visibility, also for those members and for the others, what that person can offer, what is the potential. So it might be someone called like career mentors, to give some hints about how it can be mentioned on LinkedIn profile, what can be mentioned there. And for instance, all the stuff like this one, like I'm active in Brno Python Pizza, I'm interested in what's going on around Python. This all can be and should be mentioned there for those candidates. It can be doing with those members dry runs, mock interviews to prepare them for the hiring scenarios. You know, there are some typical questions that are being very often asked in the interviews, so we can do some dry runs with the candidates to help them have that self-confidence, and it is then really visible in the interviews. All of this should be a way to help them showcase their skills, their passions, their potential, what they can offer. And many candidates are just shy. They do not write it down. And when there is the first review of those CVs, it's simply, if it's not there, those candidates might not be chosen. And it's a pity, actually, because many people are really passionate. They have a lot of hobbies that they are interested. They just do not think it's important to sell it, to write it down. And the other way is networking. And this is also kind of networking what we are doing now. We are learning each other. You can share about the positions, you know, now about Atacama is hiring, Red Hat is also hiring. So you can just share all this information where there are places to find new jobs. The other way might be also referrals. Many companies have big referrals programs. It's usually beneficial for both of the parties. So to summarize, IT communities bring a huge benefit, not only to those candidates, not only to the members in upskilling, in learning, in growing, but also to the IT companies, and in the end to IT managers. Thank you.
Thank you, Barbara. Great talk, and I see somebody coming up. Are you the next speaker? Are you Pavel? All right, so let's get you set up. And Pavel will be talking about building a web framework in the year 2024. Are we done? Oh, we're almost done. Okay, so Pavel will tell us all about how it went last year, I assume. There we go. All right, stage is yours.
My name is Pavel, and in 2024 I decided that it's a good time to spend it by building a web framework. So I know you might be asking, why would I do that? There's plenty of frameworks already. Well, I thought maybe it would be nice to have a framework similar to React, but write it in Python. But then I realized Python is backend and React is TypeScript, so how could I do that, right? Well, I decided that it might be possible with the correct technologies. So what were the goals? First, I wanted to create composable components that I can kind of compose together to create layouts and to create working HTML documents. I wanted to use a rich typing system. I was inspired by TypeScript, and I like how it's everything is typed and so on. I didn't want to write HTML, CSS, or JavaScript in anything else than Python. Well, actually, I wanted to avoid writing JavaScript. So there's like I'm not really writing JavaScript. I will show you later. And I wanted to maintain readability because you have a huge chunks of text and you still want to have good readability. And actually, I wouldn't use any state like you have in React, so it's not that similar to React. So let me introduce you to Ludik. Why did I choose this name? Well, I needed a short, memorable name that is available on pypi.org, and you wouldn't believe how many words are already taken. So yeah, it translates to something like spontaneous playfulness. It seemed like a good name. So here, let me show you what it looks like. Well, you import some HTML classes from Ludik, and you can start writing your HTML structure. Well, you might have noticed that the examples here are not all of them are valid. For example, div cannot have the href attribute. HTML can technically have body as the first element, but well, it's not correct. So yeah, you get type errors if you do something invalid, which is pretty nice. And also another thing, in PyCharm, Visual Studio Code, you get autocomplete. You can see what the attributes are possible to use and what are its values. Well, you don't always remember all the possible values for attributes. So it's a nice feature as well. Now let me show you some components, what it actually is. Well, Ludik already has a built-in catalog where there are some components, and it saves you from writing a lot of boilerplate code. For example, the table here, it would be much more text in pure HTML, so it's less code. And you also can attach some CSS there. First, let me show you how you define this component or how you write it. So example can be this simple link component. It doesn't really do it doesn't have many more features than the hyperlink attribute in HTML, but it's a good example. So here I define the class link, I subclass the component which is part of the Ludik framework, and I have two type variables. The first one is string in this case, but it can be basically any other component. The second one is the type of its attributes. So in this case, I name it link attributes, and this is the definition. And actually, link attributes is type dictionary, type dict from the typing module. So it, again, it adds a lot of autocomplete for your Visual Studio Code or PyCharm or whatever you are using. And then you implement the render method. Here, it's a very simple implementation. I just return the HTML element, basically. But I could do something more fancy. Here, I want to open new tab in your browser when the link is external. Well, yeah, I can do a lot of stuff. And what I can also do is I can attach CSS to the component. So here I say that the component has the class link, and I can add CSS there. And the nice thing is that I also get autocomplete and type errors if the attribute doesn't exist. So now let's talk about writing web applications with Ludic. It already supports natively Starlet. It also has a plugin for Django. And here I have a simple endpoint where you basically you can return components or elements directly from the endpoint, and you can basically do you can build components however you like. Now let's talk about HTMX. That's a JS library which enriches standard HTML with HX attributes, which add dynamic behavior. For example, here I have a button, and when you click on the button, it will get replaced with whatever happens, whatever is the response for the post-clicked endpoint. Yeah, there are already a lot of libraries like that. I decided to use HTMX because it got quite popular in 2023 or something like that. So, and in Ludic, it's good because it allows creating dynamic content while never leaving Python. So let me show you a simple counter example. This is a component that will render two buttons, which increment or decrement the number in the middle. So how do I do that? Well, I create a simple component. In this case, it's a function. It could be a class as well. I register under the counter endpoint, and it has one argument, which is a number. I want to return div, which has a ID counter, and I give it the two buttons and the number. And now I need to add the HX HTML attributes that come with HTMX. So I have hxget, and that is what is called when you click on the button. And when you click on the button, the response from this endpoint is used to replace the hx target, which is a HTML or CSS selector. So what happens is that I click the button, this counter is called, the response is taken, and the div is replaced with the response. So I can modify the HTML like this. And the good thing about this is that I can use the counter anywhere I want. So for example, this is a page that is valid HTML document. I put the counter anywhere in the HTML document, and that's it. I have dynamic content, basically. So another thing that is good about this approach is that I can simply create layouts with Ludic. For example, the center is part of the Ludic catalog, and I want to say that all the content will be centered in the middle of the page. I add a sidebar there, so those are just Python classes. I add two buttons that are one above another, and I add another stack, which is the main content. There will be some title, text, and some actions that are in line. And depending on the context where the buttons appear, either in stack or in cluster, it gives them different rendering. And this is the final result. It looks like Bootstrap in 2011, but you can style it. Another thing is that you can use these Ludic components with f-strings. And so if you have a long text, you can make it look much nicer. And it's safe to pass user input there. That wasn't easy to solve, but it should be safe. You can check the source code. So yeah, go check getludic.dev, give me a star on GitHub. Thank you.
Thank you, Pavel. And I see Yazan is already coming up. All right, so can you connect HDMI to this computer? And this will be a talk about using Python for an iOS backend. I'm looking forward to that. All right. So how many of you use iOS? So that half, okay. And we're good to go. Take it. I don't see the signal.
Now we do.
There we go. Okay, stage is yours.
Hello everyone, my name is Yazan and I'm a software engineering student at the Czech Technical University, unfortunately. But fortunately I'm a part-time developer as well at Barclays, and I've been doing iOS development for the better part of 2 years now in my free time. And my topic here will be why/how I use Python as a backend in iOS development. So first I would like, before we dig deep into it, I want to emphasize on the keyword backend. Whenever I mention someone that I use that I use Python for iOS development, they instantly assume that I use it for the mobile side of things, which I want to emphasize, hell no, I do not, and I do not recommend anyone to use it for that, for two main reasons. One being performance issues. Due to the interpreted nature of Python, it raises a lot of performance concerns, especially when comparing it with compiled languages in the industry like Swift and Kotlin, which are built from the ground up for app development, providing very high efficiency, which then Python cannot compete. The second one is lack of native support, such as push notifications, GPS, camera access, and Touch ID authentication, and much more. And even though frameworks like Beware have been coming up for Python to bridge the gap, it's still, they're very immature, they lack community, and for the things they do provide, it's not as seamlessly integrated. So why a separate backend? There are multiple good reasons, and the first one would be rapid iterations and updates. Having a backend separately from the main app code base enables you to update the code at a much faster rate, because you essentially are able to skip the App Store approval process, which takes generally around a day and can even take 2 or 3 more days. So essentially skipping that process allows you to push features, fix bugs, and push that quickly so the users can remain happy and they do not need to download another update for the app. Second reason being the reduced app bundle size. This comes in naturally, as whenever you have the code base basically split in two, the app size becomes smaller, leading to faster download speeds from the App Store and a snappier on-device experience. Third one we have is separation of concerns. This is generally encouraged in the field of software development, where you have the main code base for the app care about views and view state management, and have the backend care about the database, business logic, and user authentication, and all of that stuff. There is a fourth reason, which I forgot to put there. It's essentially when you have a standalone backend, it enables you to open a door in the future wherever you want to make your app cross-platform. So we're talking about iOS native apps here. So in the future, if you want an Android code base, you can essentially have that built at a much faster rate and just connect it to the backend. So I want to start talking about some frameworks that I use and tools to develop the backend. The main one and the tool that I use to connect everything together is Fast API. It's one of the relatively new web frameworks in Python that's been gaining a lot of traction recently. Maybe not as new as Ludic from the talk before, but it's been gaining a lot of traction for more than one good reason. First one being its simplicity and flexibility. Compared to other frameworks that are more mature and popular in Python, like Django and Flask, it offers a solid middle ground in the sense of it's very easy to get up and running and started with, yet you do not sacrifice any performance, and you have solid, strong, and production-ready APIs. The second one, the most important one, is its asynchronous capabilities and performance. What does that mean? It means that Fast API endpoints by default are able to handle concurrent requests with minimal overhead because it's built on the async IO Python module. And this provides an invaluable performance boost for any app that requires quick API responses. The third one, which is a pretty cool one, it's seamless integration with Pydantic. That means fast API endpoints automatically validate incoming data and enforce their types without any manual validation on your end. There's a pretty simple example here in the code snippet. It shows a user create model, a Pythonic model, and a post request to create the user, modeling how the user data should look like upon account creation. And the post request doesn't really do anything except returns a successfully created message. And here's a Postman screenshot of me sending a JSON body with an invalid, badly formatted email address. Yeah. And yeah. Could you hear me before? No, not the same. Okay. So here's the Postman. Is it even on? Yeah. Yeah. Okay. Here's a Postman screenshot of me sending a JSON body with an invalid, badly formatted email. It says das. Is it on?
Can you use these?
I can use this. I'll use both. And it automatically detects that the email is badly formatted. It tells you that by returning a 422 status code, as well as a detailed message that the value is not a valid email address, without any logic on your end. So those two last points are essentially what caused a lot of people to switch over to Fast API. And for the other part of this talk, I want to show you a demo of an app that I've been building. And so after the demo, highlight some notable features of the app and tell you how I use Python and other frameworks to achieve them. So before I show the demo, I want to give a bit of context. The app is called Voyago. Its main objective is to ease the process of travel planning, as well as it being a social media kind of app. So usually whenever you want to travel somewhere, you end up searching Reddit or asking people, where do I go and what do I do? And people then scream at you in the comment section because someone asked the same question 2 days ago. Or even you pay for a guided tour. Voyago intends to be a one-stop shop where you just tell it where you want to go and how many days. And then it gives you a full itinerary of your trip plan as well as a board. Okay, for time's sake, I'm gonna stop. And so you have user profiles where users share their travel boards as well. And from the demo, I can highlight 3 notable features. The first one being image pooling, second one being travel board generation, and third one being the user profiles and user authentication. I'm gonna start with the least interesting one. I think it's image pooling, but it's a very good example of why having a separate standalone API is very beneficial and helpful for app development. The way that Voyago is able to work is that you need to have a valid image of every destination possible in the world, no matter how niche it is. And since I cannot just go everywhere and take a picture of everything and upload that to a database, I'm having to rely on multiple upstreams and multiple APIs, as well as users' own posts. So if I ended up handling all that logic on the app code base, I'd need to manage multiple services, have multiple network clients, pull everything together, and somehow integrate pagination into that. But when I have an API, I can just do that logic behind the scenes and then expose a singular endpoint, which then the app requests, sends an HTTP request to with maybe parameter count and page number for the pagination. And that ends up being very useful, especially when you want to open the door where you want to create maybe an Android code base. The second one is travel board generation. When I first started playing with the idea of Voyago, I knew that I wanted to use some sort of LLM. However, as soon as I started playing with them, I realized that I cannot really fix or predict the response format that the LLM will return to me. So it made it pretty much impossible for me to parse the response I get into my desired structured object. This made me pretty sad, but then I realized that the OpenAI Python SDK, somewhere on the documentation, it said that I can integrate it with Pydantic and actually make the response of the LLM conform to Pydantic model and not just return me a string as usual, but return the object of the Pydantic model itself. So this is an example of how it was done. Here is the code that works with the completions API. And just here, you can specify the response format, which is a Pydantic model, and then the method itself will return an object of that model as well. And here you can see the model, which consists of other Pydantic models, and they consist of others, so I just didn't put them there. But this feature is basically what made the app idea possible. If it didn't exist, then I don't know what I would do, to be honest. But the third thing would be user profiles and user authentication. Typically, when you have an app that you want to store user data and you want to authenticate users, you need relational databases and auth providers and so on. And sure, I could do my own auth flow with JSON web tokens and refresh tokens, and my professors at university would love that, but it's a Stone Age approach in my opinion. So I just ended up using Supabase, which is a backend as a service. If anyone here used Firebase, it's an open source alternative for that, which the main difference is that it doesn't tie you into proprietary vendors like Google Cloud in the case of Firebase. So what you can expect it to give you anything that a backend you'd expect from a backend, that being auth providers, edge functions, cloud storage, and databases. So what it also gives you is a Python SDK, which you can then integrate with these services via code. So you can perform database queries, listen to state changes, update auth states. And then what you can do is the similar approach to what you did with the rest of the backend, is you wrap this functionality in a method and then wrap it again in a fast API endpoint, and then your app can communicate with the backend through that, manipulating auth states and communicating with the database and so on. And that's how I use Python and its frameworks for iOS development. And thank you for listening.
Thank you, Yazan.
You're welcome.
And that was the last talk before another break. This time we call it a short break, not a coffee break, so be quick. You can still get coffee, though. Data analysis, you dream of being replaced by a shell script. I think I've been replaced by this here. So the next talk is how to connect with a complete stranger by Nofar. Stage is yours.
Thank you. Okay, hi everyone. How are you doing? How was it so far? Good? Yay! Woohoo! You're still awake. You are the survivors. You survived. Very nice, very nice. My name is Nofar. I know it's a bit hard to pronounce. So it's like no far, not far away. Okay, like nedaleko. Okay, so I think it's the easiest way to remember it. I'm from Israel, and actually I don't have any connection to IT or Python. For me, it's like totally Chinese. Interesting Chinese, but still Chinese. I'm a storyteller, and what is like there is one thing that I care a lot about is connect, like how to connect people, and specifically, I don't know if you see it, like how to connect with complete strangers. Like for me right now, most of you are like complete strangers, but maybe in a bit it will be like less. So let's dive into it. How are we going to do it? So we're going to have like 3 stages, how to connect with each other, because soon enough we're all going to have mingling, you know? And instead of being only with your friends, maybe we can open up to other people. So do you know this phrase, don't speak with strangers, like when we were young, right? Do you know it? Yeah? So actually please speak with strangers. At some point, all the people in your life were strangers. So it's really interesting to think about it. And right now it might be your best friends, okay, or loved ones. So it's the most magical thing is just starting to connect. So how are we going to do it? Three things. I think I will pick the red one. Maybe you will see it better. So the first stage that we're going to speak about is the warm-up. What does it mean? Warm up. Can you see it? Yeah, okay, brilliant, brilliant. Warm up. Warm up, it means that even before you're going to approach someone, and we're going to speak about it in a second, but before that, you want to prepare yourself. What does it mean? Let's say, this is my phone. Let's say that I'm here right now in the Python event, and I'm going to be with my phone, so it's not approachable, right? Like people wouldn't necessarily come and speak with me because I seem to be busy. And this is, I think, the most difficult thing for us. Because when you have it, you feel like safe. I'm busy. I have something important here. Come on, you're just scrolling down. It's not that important. But we need to be confident enough to put it aside, okay? And to be present, like to raise up our gaze. And even our body language, we want it to be open. So if I'm without my phone, but I'm going to be here, sitting like that. Again, it's not that approachable. So what I want to do is my body language want to be like open, not like that, but open, and to start looking at people. So it's like, this is the warm-up before speaking with anyone, just to have this mindset. Yes, I want to interact, okay? This is the first thing. Are you ready for the second one? Like, yeah, we are. Okay, good enough for me. Okay, so the second thing, I call it the hook. So I know this is one thing that people are mostly terrified about, like what I'm going to say. Come on, like what I'm going to say. Okay, there is a stranger there. What, I'm going to walk and say, hello, my name is, come on, it's not natural. We want to do something else, right? So what are you going to do? So there are different techniques, but the bottom line, I'm going to say it right now, right away. It's not important what you're going to say. Shocking. Why it's not important? Because people here want to connect with each other. Not only here, generally. We're friendly creatures. We want to speak with other people. It's fun for us. It's nice for us. Of course, if someone having a phone call right now, okay, so no, I'm not going to go to this person. But generally, overall, we want to connect with each other. So whatever we are going to say, and I'm going to list here a couple of ways what to do, but whatever it is, it will be good because you just need the first hook, you know, to pull the string, like to have the first connection to speak with someone. And then you know it's going to start rolling. So what are we going to do in this stage, in the hook? Any ideas? What can we do? Yes? Give a presentation. If he likes, amazing, thank you. Ask questions. It's a great way to start a conversation. If someone here was on stage, so you can also ask him, how was it to deliver the presentation? If someone is here, so you can ask, oh, is it your first time in this Python event? It can be even like a small question, it's like, do you know if there is like, I don't know, hot water or something for tea? Okay, it can be something small. Of course, it should be a question that you care about, okay? Obviously. So first it can be different kind of questions. It doesn't matter which one. It can be even, where is the restaurant? I'm lost here. And then it's like, oh, are you new here? Actually, yeah, it's my first time. By the way, I'm not far. Nice to meet you, okay? So it can be something really simple. It doesn't have to be extreme question. What will be my question? It can be something really simple that you want to ask the person. So amazing. Question, one thing. What else? What can be the hook? Oh, thank you. No, I didn't ask Moises to say, no, not at all. A compliment. Amazing. So it can be something technical like, wow, I like your browser. It's so nice. Where did you buy it? Okay, or, oh, your t-shirt is so cool. Or, I loved your talk. It was very, very interesting. And again, of course, say something that you really think that it's true. Okay, don't make up something. But like if you see something that you like, whatever it is, yeah, say it. And then in a second, we're like, come on, we all like to receive compliments. It's really fun and nice. And then we're starting the conversation right away because it's super natural for us, right? So amazing. So it can be also a compliment, something nice to say to other people. It can be also like something, the third thing, the third hook can be about food and drinks. And this is the best place to start conversations, okay? I'm coming to pour myself like a glass of water. I'm taking a sandwich, even like I can state something as like, oh, are there any vegan sandwiches, Moses? No, they are not. Oh, too bad. And then maybe another person say like, oh, yeah, I also know this, and the conversation will start. Okay, so it can be anything. It can be something that is really small. Okay. For instance, before that, like I talked with Julia. Did you all see Julia? Here you are. Did you see Julia? Thank you, Julia, for being here, first of all. And we started speaking because I said like, oh, I love merchandise. I'm going to take it all. I just stated a sentence. I didn't spoke to her and said, I didn't point at her. I just said like, I love it. You can say something that is obvious for you. Okay, it can be about the weather. Oh, it's so freezing here. And another person said, right? Yes, this weather nowadays, it's like that. Okay? So it can be something like that you are going to state, to say out loud that is, again, correct about you or your situation. And then the connection will start and you are going to roll. Wait, I'm just going to see the time. Okay, good. Amazing. So we had the second part. And the third part, because until now, I just maybe taught you or you heard how to start a conversation. It's not how to connect. Connection is another stage, right? So for this one, we will need the third stage. Ready for that? Ooh, yes, okay. Better. And it's called meeting the extraordinary. Oh my God, it's a really long word. Extraordinary. What does it mean? For this, I need your collaboration. Are you willing to collaborate? Good, you don't have any other choice. Amazing. Ella, can you please come on stage? Woo! Okay. We're going in a second, you're all going to get up on your feet. What? Huh? Yeah. You're all going to get up, really, literally, and go here around. Wait, in a second, not yet. I love your enthusiasm about it. Okay, we're going to play a really short game, and we're going to do it super quick before Moises is going to kill me. Yes. So it's gonna be like that. I'm going to complete stranger, okay? And I say, hello, I'm Miss Druckmann. So I'm going to say Miss or Mr., okay? And my last name. Miss Yamal. Okay, the handshake is really important. It's like our first connection, it's important. Okay, so from now on, I'm Miss Yamal, and she's going to be Miss Drukman. I'm going to go around to another person, let's say it's another person, and I want to say I'm Miss Yamal, but I forgot. I didn't remember. So I'm going to be I'm Miss Forgotten. Yes, I'm sorry. So from now on, she's going to be Miss Forgotten. Okay, clear? Let's see with which identity you are going to end with. Come on, get up, really fast, really fast. Start introducing each other. Thank you, Habibti. Keep going from one person to the other with your new identities. Come on. Keep up. As many as you can. Ten seconds left. 10, 9, 8, 3. Okay, great. And get back to your places. Get back quickly. Get back. Get back. Sit down. Sit down. Okay, good. Sit down. Okay. So it's our last minute of this talk, so we'll do it fast. Okay. You ended with what was your Mr. Halushka? Is it correct? Yes. Okay. Do we have here some forgotten? Please raise your hand. Right now, if you don't remember the last name, please raise your hands. You're many of you. It's such a big family. Why is like that? Because it's really hard for us to remember someone's name, especially if it's not from our own region, from our own hometown, okay? So it's really hard for us to remember this detail. This is why we want to get to an extraordinary thing that is not just our names. So if the name is unique, ask the other person for the name and make the connection. It's amazing. But also say something more than, yes, I'm an engineer, I'm an IT, No, I want something else that is a little bit unique about you. Something about your hobbies, things that you really like to do. In other words, put your heart in the middle. Like if you really want to connect, put your heart in the middle, and I think it's gonna make the whole change. Thank you so much. Okay, there is a QR code. No, there is a QR code here. I have a WhatsApp group. It's a quiet, silent WhatsApp group that's called the name is Brno. So speaking of connecting with other people, so I put here opportunities to meet each other, to connect with each other. It can be like hiking, board games, whatever it is, meetups. So it will be even easier for us to speak with other strangers, okay? Because sometimes we need the settings, right? Because we don't have these beautiful conferences every day. So you can just enter this group and join in. Thank you.
All right. So hello, I'm Boris, apparently. The next talk is supposed to be more technical again about terminal plotting. And yeah, we have some more setup. Right. So how many people did you switch names with? Is there anybody who got up to 5? or more? No. Okay. Yeah, yeah, yeah. I mean, you can do more of this after a conference. There's supposed to be some what's it called? Chill session. Yeah. Networking session. Oh, we're done. Okay. Honza.
Okay,
show us
do you
some
hear
coding.
me? Do you consider it to be a good warm-up? If so, so hello strangers. I now have about 10 minutes to try to connect to you, so I'll try doing that by speaking about plotting in terminal. So, okay. So, I just hope that the QR code is still visible. I can make the font a bit smaller so that, hopefully, no, I cannot, never mind, doesn't matter. So, yeah, exactly, but I think it's maybe the apps would work. Doesn't matter, you'll see it later. Yeah, I shared with you if you want. So, what are we speaking now about? Just to start with, the warm-up. I wanted to be able to do things like that in terminal because I'm running my commands in terminal. I like processing data in terminal, etc., etc. And I also wanted some visualization for that. So I wanted to plot things like that because very important if you want to know how the check jet fuel consumption is correlated with the number of successful climbs of Mount Everest of the particular year. This is perfect, and you want to see it in the terminal. So that's maybe the first part of why I would do that, and also like, of course, it is cool, you know, that all the clever guys in the movies, when they're doing something on the computers, they have black screens with, unfortunately this one is white, black screens with white letters, and they're doing magical stuff. But actually, other reasons, of course, you've already probably seen some apps in the terminal that actually provide graphical output, like the different graphs of your CPU utilization, things like that. And it's actually quite informative, more than just numbers or tables of numbers. So which is, you really want to have some visualization of the output. And also, if you go far enough, you can just like even copy the screen and put it into your documentation, which apart from the examples also can have drawings. So if you want to do that, how would you approach it? Let's try to approach it from the beginning, but we'll get to something more clever than just beginnings. The modern terminal emulator is your friend, is your weapon. There's like a lot of things that it does. It provides you with some area, let's say, that has some size. You know that size. It can draw in many colors. Typical modern terminal supports completely true color, RGB, whatever you want. It supports letters from different groups of characters. So you can use regular ASCII, which looks like really nerdy, or you can use the Unicode symbols that look more human. And it also supports, if you need that, the so-called alternate screen that turns off the linear standard way of working and allows you to use the screen really as a canvas. So let's say that I want a simple bar chart, and that's something that everyone can do. If you want to create a small bar chart, horizontally oriented, you can do it yourself. Just the code that you can write. We will not read it, but basically you just multiply the one character so many times and on the screen that it looks like you want to see it. So that is like 2 lines of code, and you already have your first visualization in the screen, in the terminal. You can use, as I said, more fancy, more human-looking thing using the Unicode. Then you can add the colors. With here, probably using the true colors of those 24 bits is nice, but because you can really reproduce whatever colors. But what's probably more common is that you somehow want to fit your output within the terminal. So using the standard 16 colors that are provided by the terminal, which has its tricks because this is customizable. So then not every rendering that you want will be exactly like you want. You do that by sending special escape symbols to the terminal, which is somewhat tricky. So I recommend to use a library for that, such as Rage, if you want to implement something like that. But actually, it looks like that. You know, these ANSI escape codes are like part of your prints if you want to just be really like low level. And this produces something like that. So that's like you can use the colors with. Those are the standard 256 colors of that the terminal can use as an extension. And I have a second example for you, and that's like I want to create a simple scatter plot. Again, this is something that you can do if you have like 10 minutes in your spare time. You can create a scatter plot because you create some arrays and then you just put random characters within the array and then just you print or join the array, so it will look like something like that. I'm creating a map of the cities that are large enough in the Czech Republic. The data are downloaded from artificial intelligence, so I hope just that the positions are correct and the colors are not such bright, but you at least see the biggest cities with their first names, letters. So I'm perhaps, what if I wanted to add the path of my train trip to Brno? And now probably I shouldn't do it myself because, I mean, probably there was someone that spent their minutes, hours, meant maybe even weeks implementing things like that, and I probably don't want to do that. So we can use libraries, and there is like a huge variety of different libraries that attempt to do a bit of terminal plotting, and the two most interesting of those that I found were Plotil, I hope I pronounce it correctly, and Plotext. And so I'll just like very, very briefly, because we don't have so much time, show at least some examples of what they do. Both of those are just works of one single person, which unfortunately means that if they don't feel like developing new stuff, then they don't, and there's still a lot of things that is lacking from the libraries, but they are quite capable already. So this Plotil by Matto Ipen is centered around using the Braille characters when you want to plot something, which is quite cool because these are like different dots that you can arrange in different orders, and then by doing that you can create lines. And so I'm now doing my example. You see that it's probably a bit less complex because I'm using a library, so that I don't have to do any extra stuff there. And I can already create my trip from Prague through some other cities that are on the way and to Brno. And I also have the nice axis that's like, it would be a nightmare to properly implement the description of axis because that's so complex. It called, yeah, that's that. And it can also show histograms like that. These are like some random numbers, so that's not so important what is there. The second library it's probably the most complex one for drawing in terminal because it contains a lot of different graphs. Is Plotext, again by some person I don't even know the name of. I just know his nick, Piccolomo. Okay, so that's the one I used for the first slide where you saw the line plot. And again, like this really provides a lot of things, and apart from line graphs, it also creates histograms that are overlapping each other. That's like really nice, and nice colors. Again, nicely described axes, even better than what the Plotil did. So this is really nice, and it can also show live plots. That's amazing. That's really cool with streaming data. And what if we could actually use Matplotlib in the terminal? And that's like a hack, because I really don't like that, because it's just somewhat violating the principle of terminal showing nice letters. There is something called like Kitty protocol. It is a way how to put actual pixels within your terminal, and based on that, you can actually download something or import something that's called Matplotlib backend Kitty, that allows you to forward the output of Matplotlib to terminal directly. And so you can download any example from the gallery of Matplotlib and just put it there. The only drawback I saw is that it somewhat does not respect the background color, But apart from that, it just completely renders everything in the terminal. And this is supported in many Linux terminals, in many macOS terminals. And if I wasn't able to run it in Windows, so I don't know, but perhaps there is a way how to do that. And if I'm not mistaken, that was my 9 minutes and 40 seconds, and I still have 20 seconds. So I guess just that plotting in terminal can be fun. It can be sometimes even useful. That's also an important part. And if you are using proper libraries, it can be easy. And now the QR code is complete here, so you can. There is a link to that, and there is also a link for a small tool that I wrote to just use those libraries in terminal just without importing in Python, but just running as scripts. And with that, thank you. And yeah. Also references when you download that, but.
Thank you, Honza. Hello, Christian. Oh, could you, can you use your laptop?
Is it a PDF or?
It's just a PDF, yeah.
Okay.
All right. Headset. Yeah, sure. Microphone. All right, so Christian will tell us about Python, physics, art, and how to connect all of that together to create pretty pictures. And I think due to using the computer
Excellent.
already there,
Yes.
we are all set up now.
Yes, I think we are already set up. Yes, perfect. Can you also hear me?
Right.
Excellent. Okay, so yeah, welcome to my presentation. This is the very last presentation of today, so hopefully it's all over now soon. We have already seen quite a few interesting talks, starting from random numbers, over reading genomes, now even plotting in the terminal, or how to connect with strangers. And I would actually like to end with how we can combine very tiny bits of Python, a little bit of physics, and then also a little bit of art to create what are hopefully pretty pictures. So, but before we do this, I would like to ask a kind of really deep fundamental question. What is this all for anyway, right? Because, I mean, if you look at this XKCD comic, you see, in the end, this is all meaningless, right? Because, I mean, if we wait long enough, eventually the Earth will be consumed by the sun, and so what gives? But regardless, in the context of writing computer programs, there are a couple of reasons why we would want to write the program. One of these reasons, of course, could be some business interest. Sometimes we also would like to answer some interesting science question. And every once in a while, something else is going on. And in what follows, actually very much something else is going on. And this something else was inspired by art in this case. So we have this English artist, her name is Bridget Riley. And a couple of years ago, I was in a museum. I saw this painting here, this oil painting. I'm actually not even sure anymore if it was this exact painting, but this is one you can find on Wikipedia, and low resolution and fair use and all that, so that should be fine copyright-wise. And I found this quite intriguing. I mean, I like the colors a lot and the tiles, and so it looks pretty good. And you see, it's 1990, all on canvas. So that's a painting, that's completely analog. There are no computers involved, but I have a background in computational physics, and looking at this, I thought, maybe, just maybe, we can create something similar, which looks a bit like that with a computer, maybe with a computer simulation, maybe even with some physics behind that. And that's exactly what I did try, at least. And as always, with any good project, even if you do it on a computer, I started out analog. So just made a few drawings here. So came up with some lattice in my sketchbook. So this is not for this presentation. This is actually my original sketches from my notebook. And then I just have some kind of lattice in two-dimensional space. So just a couple of grid of points, basically. And then we have these tiles. We have space-filling tiles. Those are these funny shapes here. And then, of course, there's some mathematical aspects come in. We can use two integers, an integer tuple I and j, to address each tile, like so. And then, of course, for all the tiles, we can also define their neighbors. So we have an upper neighbor, a lower neighbor, and due to the peculiar kind of lopsided form of the tiles, the left side neighbor and the right side neighbor, it's a bit lower down here, a bit further up here. But anyway, we can write down in terms of coordinates what the neighbors are. How we want the neighbors to interact. And what do we actually mean by interact with the tiles? Well, we mean, of course, physics. And when we mean physics, in the case of this example at least, we are talking about some physical model. In my case, I selected a simple, at least in a physicist's term, model coming from the study of magnetism. So basically, this is also called a spin system. And now we say we have all these little tiles on our lattice, and then each color stands for a value. This value can be, for example, 1, 2, 0, 1, 2, and so on. It's really only important that they are all distinct values. And then, of course, we associate colors with values, and then we also define some kind of interaction. When a physicist says interaction, what they always mean is there is some kind of potential energy involved. Potential energy is something which always wants to go down, right? So I mean, just if you have a glass of water or water in a river, it wants to go from a high energy state where it's up in the mountain, flows down into the valley where the energy is low. And just like that, for our grid of tiles or lattice of tiles here, we also have an energy function, which kind of the system tries to minimize. The fancy way of writing down this is then called a Hamiltonian. And I don't want to bore you too much with the mathematics. I mean, of course, we can talk about that, but that's maybe not for now. The important thing here is that if we have two tiles of the same color, this is a contributed energy. So basically, this is favorable from a point of energy. And if two different colors are touching each other, then this does not give you a favorable contribution in terms of energy. Now, if you are a real genius and you are really good with pen and paper and mathematics and all that, you write down the Hamiltonian of the system and you derive all the physical properties of the system from it. But unfortunately, I'm not a genius, and so I have to use a computer. So we are doing some computer simulations of that system. And in particular, we do computer simulations to study the thermodynamics of our system. What do I mean by thermodynamics? Again, we have all these fancy terms, but what this really means is we just turn on the temperature. We study how this thing behaves at different temperatures. We make it cold, we make it really hot, and then, of course, this being a computer simulation, we can also choose pretty much any temperature in between. Okay, then to actually perform this simulation, we use pretty much a standard algorithm from statistical physics. It's called the Metropolis Monte Carlo algorithm. So this gives us is a stochastic algorithm, which gives us a sample of states. And again, I don't really have time to go into all the details of the algorithm. But what's really interesting here is you start with some initial configuration, so a certain arrangement of the tiles, of the colors on the grid, and then you make a little perturbation, and then you see how the energy changes. And if the total energy of the system goes down, you immediately say, okay, I'm good, I like that, I will keep this. But if the energy goes up, then you only accept this with a certain probability. This is like that. And here already we see we have a random number here. So normal pseudo-random numbers, nothing fancy. But here you have a really good example in computer simulations. That's exactly one of these places where you need those fancy random, or not really random, but almost random numbers from a computer. And then depending, of course, on the temperature, so the temperature is a bit hidden here. In this beta, it's called the Boltzmann factor, which is basically the exponential of minus the temperature. So this goes then in here, and then by that you can then basically see how the system will look like at different temperatures, and of course also for different other values of your interaction parameters. Lots of things which you can tune, but at the end of the day, you set something, and then if you're happy with it, you stick with it. If you're not happy with it, you change it. I mean, it's a computer simulation. So in the computer simulation world, you are basically the god of your system, so to speak. And then finally, the only thing which is left is, of course, our old favorite plotting library, matplotlib. Well, not in the terminal in this case, unfortunately, so let's just use it in a regular way. So we just put then the results into matplotlib, and we can then generate pictures out of it. Well, how does it look like? Looks a bit like that, okay? Now what's really interesting here is, on the left-hand side, this is the initial state. So this is completely random. There is no simulation going on, no temperature. This is just, you have 6 colors in this case, and you just select them at random, and that's your initial state. But then you turn temperature on, and then you let the simulation run for a few seconds really on a modern machine, because that's all that it takes for such a small system. And then you see something really exciting happening, right? I mean, you have all these different colorful areas. You could think of that as magnetic domains, which form, and you definitely see there is quite a different visual nature now to the picture. And this also, of course, depends on temperature. So if you turn the temperature up, it gets more chaotic. If you go down in the temperature, it will get a bit more regular, and then depending on all these settings, you can basically generate every kind of behavior what you like. Okay, so with that, I come already back to my initial question. Again, what is this all for, if you see in the comics? Well, I still don't know. I mean, 4 or 5 billion years from now, the sun will turn into a red giant, will swallow up the whole inner solar system, including the Earth, and we're all gone, so what gives? But at the very least, we could make some pretty pictures along the way, and for me, that's already something. Thank you for listening.
Thank you for a beautiful closing, Christian. And that was the last regular talk of the day. But it was not the last talk of the day, because now we will have some community announcements. So if you are organizing or involved with some Python event, conference, a meetup, and so on, please form a warm up, form a queue somewhere around here, and you will get the mic. You will get no slides, just the mic, and you can promote your event. And I can see some people are already lining up, so please introduce yourself.
Hello, 1-1. Hello everyone, I'm Jake. Probably you saw me in some events that I'm gonna promote now. First of all, the big one, EuroPython 2025 is happening, right? So this is like a massive one, and it's happening in Prague. So make sure that you come up. First of all, we have newsletter at the moment that's happening. You can just submit, and all the newsletters will come in. We are not spamming, so don't worry about that. Discord servers and everything will come later, and we will do that also through the newsletter. So also, I think we got all the talks now, right? So the talks are in. We're just trying to select the best ones. So don't worry, there's going to be plenty of content. Now the smaller, but a lot of... what? EuroPython. Just Google EuroPython and it will just find its place. Right. Now the second event that's happening every month here in Brno, right? It's Pivo. I see a lot of people from Pivo community here. Thank you for coming. So we would like to invite you to visit. It's every last Thursday of the month. And we also look for speakers. So if you are not afraid to be on stage, or maybe if you're afraid, but after 2 or 3 beers, you're fine and still can speak, that might be your chance. It's very non-consequential. We only record it and put it on YouTube. But you can always say no. And that's happening in Art Bar, which is there. And that's it. Thank you very much for joining, by the way, today.
Thank you.
Just holding the mic.
Doing a great job. Need a little bit more cable. So if Anushka says she's just holding a mic, it's a lie, because she found an awesome place on the south of Czech Republic. And if you are kind of, EuroPython is great, obviously, but if you are kind of bored with all that organized conferences, we have something special for you. The event will happen in Třeštický Mlýn, which I'm sorry for all the foreigners, it's hard to pronounce, but it's a really lovely place. And it's going to be something different. And what it's going to be, it's really up to you, because it will be in a barcamp style conference, something, and you can all participate, you can all join us. It will be in the middle of September this year. We have a lovely website, as you can see here. There is a way how to subscribe to our newsletter there, and we organized that event with Anushka and Miro. And it's going to be interesting, 100%. I'm 100% sure that it's going to be interesting. The Třeštický Mlýn is, give me a sec. It's south of Czech Republic there, not that far from Brno, as you can see. And it's going to be completely up to you. The program will be based on what you want. If you want to propose a workshop, a seminar, or a morning run, yeah, I'm looking at you, Tomáš, and everybody who wants to be there can be there. Join us. Don't forget to join the newsletter, because the number of spots are really, really limited. You can sleep in a tent, on the grass, or wherever you want. There will be some rooms available as well, but not as many as tickets for a whole event. And we also have discussions on GitHub, which you can join. You can subscribe so you don't miss any news, and you can already start proposing content for the PyCamp CZ25, and it's beta, so it's testing really run, but it will work and it will be awesome. Join us. Thank you.
Okay, you saw me already. I'm Jan, and I'm one of the co-organizers of PyData Prague series of meetups. And first, I would like to invite you to come as just to visit Prague. Probably a lot of you are from Brno. It's a nice opportunity to see your most beloved city again. But no, that's probably better than Prague. No, I'm just confused. Anyway, you are invited as participants, but also you're very, 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 very much invited as speakers. So if anyone has a topic that is remotely related to Python and to data, and you want to speak, you saw that today that speaking is not so hard. Please come to us, send your proposals, etc., and we can always make a deal. And yeah, you can find us on Meetup or using pydata.cz, a website where pydata.cz. Just type that if you can, but it's not so important because it's very super sophisticated. Most Web 2.0 or 3.0 or whatever site there is. So it's basically markdown rendered, and you can go to Meetup and to our past recordings and everything, and most important, and also some social media that we also kind of have. Okay, thank you.
All right, we made till the end of the day. Where do you want it? Thanks everybody again for coming. It was I think it was a great success that we had here today, paving the road for the next Python Pizza in Czech Republic. Let's see where that's going to happen. We will remain here in the venue for the next hour until 6 p.m. You are welcome to stay with us, to connect with more people. We still gonna have something on the stage. It's gonna be some improv, let's call it that. And just like enjoy yourselves. Thanks everybody for participating. Thanks the speakers for like making the content for the conference. Thank you the sponsors for making sure that we can have this happen. So thanks. Yeah. And special thanks to the magician behind the especially to everybody like watching us online. So Piotr taking the whole stream. Thank you. Do you want to come on the camera? No. Okay, let's. Yes. Peter, thank you for joining us today. Who else do I need to thank? Oh, thank you, Alexandra, for using my camera. And yes, let's have fun.